it's just there, yeah.
Okay. So, good afternoon. And I hope we're not causing anybody indigestion. So, I think we begin the afternoon session, inviting Professor Huisong Lee to moderate this afternoon session for us. Prof, you have a, thank you.
Thank you very much, Cardinal, and it's very nice to hear you pronounce my first name very correctly, just the way I pronounce myself. Thank you so much. This session is about air. Everything is about air, and climate mitigation effort has very close relation to the improvement of air quality. And studies emphasize the huge co-benefit of the climate mitigation effort. And we will be able to listen to our 6 speakers, as well as during the floor discussions, much about this co-benefit aspects of the climate mitigation. So with that, I will open the session. And as I said before, we have 6 presentations, and also for the first time in our conference here, we have an open discussion, 30 minutes open discussion. I hope that we will have a very lively 30-minute discussions after we listen to the 6 presentations. So with that, I'd like to invite Professor Jose Lillefeld, Max Planck, about air quality and health effects.
Yes, thank you very much. Thank you very much for the opportunity to be here, participate here, and present this work. This was work that was presented also last year too, and partly also on the COP28. It was our aim to contribute to the discussion with air pollution and health issues related to fossil fuel use. Initiative was actually taken by Andy Haynes and myself, and he's also here. So thank you, Andy, for your stimulating participation. Actually, this is quite interdisciplinary work. So we have atmospheric, data science, public health, medical sciences. People have to work together to grasp this problem. Technical issue here. Yeah, the atmosphere is sort of like an integrator. So we have emissions, natural emissions, and all kinds of pollution emissions. We call them primary pollutants, but in the atmosphere, actually, a lot happens to them. Many of the gases form particles, and other gases form other gases that are more toxic. So we have transport and chemical reactions. And once this all forms hazes, pollution hazes, things are pretty much mixed. So when you measure air pollution, it's quite difficult to relate that directly to the sources. So that's something we are trying to do. And so we have multiple sources, again, natural sources. This is to a large extent desert dust. Actually, desert dust sounds natural, but it is to a large degree not natural, but it is perhaps unavoidable. And then we have, all kinds of sources, including also agriculture, mobile sources. We heard about traffic. So much of the pollution is actually in the urban environment, and we always focus on vehicles, but actually a lot of the pollution comes from around the cities, also energy production, etc. So it's our task to sort of disentangle this and then relate this to the health impact. Yeah, and this is how it then looks like when it's polluted, and you'll recognize some. It's not always this case. For example, in Delhi during the monsoon, it looks much better. But actually, the particles that are formed in the atmosphere, which are hazardous, are so small that you can't see them with the naked eye. But if you look at them like this, you can see them very well because they scatter sunlight and they also absorb. For example, this orange glow is from absorption of sunlight by the nitrogen dioxide. And then we have black carbon. We have all kinds of things in the mixture that absorb sunlight or scatter sunlight. This is the net result of it. And actually, This scattering also contributes to cooling, and this is one concern that we have, that when you take away the cooling, you get warming, which contributes in the other direction. So things are pretty complicated, but here we focus on the health aspect. So let me present you with the central outcome of this study and try to explain to you why the numbers may appear higher than the ones that you've heard before. So the estimate that we are presenting of global excess mortality attributable to air pollution is 8.3 million per year. Now, you need to understand this word excess mortality. It's not that people die from air pollution. People usually die from multiple causes, but this is what is being attributed. So an excess mortality is the mortality that happens in a particular year that would not have happened in the absence of exposure. So it's good to have the definition straight. Then out of this 8.3, which contains also some natural, still 5.1 million per year are related to fossil fuel use, which is actually 82% of what we would call avoidable anthropogenic pollution sources. Now, you could claim that not everything is avoidable, but if you, in principle, everything that's anthropogenic would be classified as avoidable. So this is a very, very large fraction. And these estimates are actually quite higher than most previous studies. And I would like to try to explain this to you. That first of all, we used a new relative risk model that is used to link air pollution to health. And we use a risk model that is based on epidemiological studies that cover the entire range of air pollutants from very low to very high concentration. In the past, this was difficult because we did not have epidemiological cohort studies in highly polluted regions, including China and India, for example, but we do have them now. So we are now able to use these risk models, which are based entirely on studies with air pollution, not proxies. For example, secondhand smoking or indoor air pollution were used as proxies. Then also we account for all-cause mortality, because in many assessments, only disease-specific mortality is being accounted for, and then it's added up. But actually, if you account for all-cause, it's about a third higher than when you just add up the specific ones. And there are quite a number of ones like neurodegenerative diseases and hypertension, for which the evidence is mounting, but they have not been part of this adding up of specific mortality causes. And then, of course, if you reduce air pollution, there's a major reduction in air pollution, and obviously this has a major also health impact or health benefit. Now, why at all can air pollution be so damaging for human health? You should realize that, you're inhaling this the whole day, your whole life. And this is creating chronic diseases. So per day, you take in some 20 to 25,000 breaths, 7 to 8 liters per minute, which is about 11,000 liters per day, which add up to more than 300 million liters in a lifetime. And the very small particles and the gases can get very deep into your lungs and even get into the bloodstream. Then health impacts include short-term ones, like when the air pollution is very high, you will be coughing or have difficulty breathing or aggravating asthma or have eye irritation, etc. But what we are most concerned about is the long-term impact, because the chronic exposure causes chronic diseases. It causes oxidative stress in your lungs and systemic. So we have pulmonary and systemic inflammations, vascular dysfunction, atherogenesis, which is basically plaque formation in your arteries, impaired metabolism, and health outcomes are ischemic heart disease, from which you can get heart attacks, strokes, cerebrovascular disease, respiratory tract infections, chronic obstructive pulmonary disease, asthma, lung cancer, type 2 diabetes. There's overwhelming evidence that these diseases are either caused or aggravated by air pollution. And there are a number of others that are implicated, for which the evidence is growing, like decreased birth weight, premature birth, arterial hypertension, and neurodegenerative disease. a central aspect of epidemiological studies is the hazard ratio. And you can see that here. And you see these solid lines and the dashed line. And the solid lines are from epidemiological cohort studies that actually use these proxies. So the good news maybe is that these lines are a bit lower. Let me first explain you what the hazard ratio is. So if you look at the dotted line, you see that when you are exposed on average to 40 microgram per cubic meter PM2.5, which are particles with a diameter smaller than 2.5 micrometers, then you have a 50% higher chance of developing heart disease from which you die. And this goes per age category. Now, these solid lines use proxies, and the dashed lines, they use air pollution data only. Now, maybe the bad news is that these lines are higher, but the good news is actually that they are more linear. So that actually means, and that's important for policymakers, that whatever measure you take, even if you're at high or at lower levels, it always leads to improvements in air quality and improvements in health. Whereas in these lines where they're almost flat, so you have to decrease the air pollution very strongly to get an effect. And then we use these hazard ratios, and then it's a simple concept actually. We have excess mortality, we use baseline mortalities, we need population numbers, and then we calculate based on this hazard ratio or relative risk, what we call attributable fraction. So this is a statistical exercise. And sometimes you hear, okay, these are only estimates, but I can tell you these are estimates based on large numbers. So they're estimates, they have uncertainties, definitely, but they're not just estimates in the sense of that you can ignore them. They are solid evidence of health problems. And then if we do that, we can make these maps, and you can see, for example, that in South and East Asia, things are quite bad. Actually, you can, if you look at the numbers at the bottom, you can see that this is not linear. So the light orange ones are like a factor of 10,000 lower than the darker purple ones. Actually, these numbers are a combination of bad air and high density of population. So we're now not looking at air pollution, we're looking at air pollution impacts on people. So, but the South and East Asia is where about 55% of our population lives, but about 70% of this mortality occurs in this region. But we also see other regions, like in West Africa and Eastern Europe and some other regions, which are quite bad. And again, this 8.3 million per year is given here, but also the mean loss of life expectancy, 2.2 years. And then we use our tools to attribute. So, and what we have done here also is we have these results for each country in the world. So if you're interested, you can contact me. I can send you this information. So excess mortality rates are per population number, per 100,000. That's a fairer way of showing it, because otherwise in the previous diagram we had also population density sort of indicating that things are very bad in certain places. But this is normalized to population. So now you see the places where actually excess mortality is high as a percentage of the population. And you can again see South and East Asia, but also Western Europe and some other parts of the world. Then if we take out the fossil fuels, you see that there are huge differences. So this actually goes down tremendously. And especially also in East Asia, but also South Asia, in Europe, also North America, Middle America, South America. And some parts of Africa less, especially directly in the vicinity, also in the Middle East of desert. As I indicated, some of the desert dust is not natural, but it's probably unavoidable. Then if we look at the disease categories, you can't read this, but what I can say is that things that affect children are brownish here, and things that affect chronic diseases, for example, ischemic heart disease, COPD, and stroke, are more like bluish. And what you can see, the upper three ones or so are to the left are North America, Germany, and the right one is China, that actually cardiovascular diseases are way more than half of the cause of this excess mortality related to air pollution. But if you look in, for example, Pakistan or Central or Western Africa, you see that a lot of children suffer. And this is mostly because of pneumonia. Many children still die from pneumonia, and this is very much influenced by air pollution. And pneumonia is a treatable disease with antibiotics, but still many children die as a result. So it's something that maybe not so well known, but many children. And of course, this has a big impact on the life expectancy. And this is what you see here. This is the life expectancy loss from several causes. In the upper left, you see air pollution for different countries, which is contrasted to the upper right with tobacco smoking. Lower left is diseases such as malaria, and to the right, lower panel is HIV/AIDS. And you can see that ambient air pollution is on par with tobacco smoking in terms of total premature mortality. To summarize, the estimate of global ambient air pollution mortality is 8.3, 5.1 related to fossil fuel use. Actually, air pollution is among the leading environmental risk, but one of the top 5 overall, like with hypertension, etc., tobacco smoking. The global mean loss of life expectancy is 2.2 years, but in some countries like India, Pakistan, Central Africa, and some others, it's more than 3 years. And this is, as I said, on par with tobacco smoking, and the final conclusion should be that phasing out fossil fuels is a really effective intervention to improve health and save lives as part of the United Nations goal of climate neutrality by 2050. Thank you.
Thank you very much for sharing the latest information on the estimate of excess mortality with all of us. And it's very striking to see the air we breathe without any much thinking, really the killing is a silent killer for all of us. That's very sobering. Let me invite our next speaker, Gabrielle Dreyfus of Georgetown University, on the bending the emissions curve. So, Gabrielle Dreyfus.
Thank you. So I'm doing an experiment and I will not have slides. So thank you to all the honorable and distinguished participants here today. It is truly an honor to speak with you. I am Gabrielle Dreyfus. I am the chief scientist with the Institute for Governance and Sustainable Development and an adjunct professor at Georgetown University. And my background is in reconstructing past climate change from Antarctic ice core records. I'm probably the only person you'll ever meet who spent time in a freezer in Antarctica. For the past 15 years, I've been working at the interface of science and policy in government and civil society. And there are 3 things that I would like you to remember from my remarks today, and that build on many of the themes we heard earlier this morning. The first is that we are facing not 1, but 2 climate emergencies. This is where time, chronos, comes in. Second, nearly half of the global warming that we are experiencing from greenhouse gas emissions is due to super climate pollutants, including some of the air pollutants we just heard about, other than carbon dioxide. And third, to address both of these climate emergencies, we need our leaders and our institutions to take action to make deep cuts to both carbon dioxide and these other super climate pollutants, namely methane. Really critically, these actions are complementary and not interchangeable. They're also essential to protecting human rights and the natural systems on which we depend. So first, 2 climate emergencies. While most of the attention has been focused on the level of global warming at the end of the century, we saw this morning that the Paris target is for 2100. And there has been some progress in this regard. Projections based on current policies and commitments suggest that human-caused emissions of carbon dioxide from burning fossil fuels and cutting down forests put us on a path for warming of around 2.5 to 3 degrees Celsius by the end of the century. But this is compared with what was a 4-degree Celsius target or direction prior to the Paris Agreement. So I do want to recognize progress in this regard. And while 4 degrees Celsius, again from that Antarctic paleoclimate perspective, that's a mile-thick ice sheet if we were to go the opposite direction, would have been calamitous, even a warming of around 2.5 to 3 degrees would effectively place nearly a third of humanity outside of the corridor of life that has sustained civilization over the past 6,000 years. It's this end-of-century climate emergency that demands that we stop adding carbon dioxide to the atmosphere. So this is the time. This is the longer-term climate emergency. Because every ton of carbon dioxide that we emit is a legacy of committed warming for our children. This is the marathon that we are running now to free our economies from fossil fuel addiction. But there is another climate emergency that others have alluded to earlier today. This is the climate emergency that we are facing today. We are already experiencing the extreme heat waves, storms, floods, droughts of a changed climate. We saw graphs of billion-dollar disasters that are becoming more frequent, almost daily extremes in India documented. And the billion-dollar disaster, these financial costs only hint at the human costs and the suffering as extreme weather, failed crops, and sea level rise drive tens of millions from their homes and fuel a global climate migration crisis. Fire season lasted a month or two when I was a child growing up in California. Now there are years where every month is fire season and smoke turns the sky orange. Indeed, experts in climate attribution science tell us that, quote, the current climate has changed so significantly that the pre-industrial world has become a poor basis of comparison, end quote. And this is with warming of only about 1.2 above pre-industrial levels. And we heard that under current warming rates, we are expected to pass 1.5 C within the next 10 years, possibly less. And because this warming threshold, the way the IPCC calculates when we pass 1.5 C, it looks at both the past 10 years and the projected next 10 years. And because there's strong evidence that the rate of warming is accelerating, we will have effectively passed that 1.5 C threshold by the time the 10-year average of past exceeds about 1.4 degrees C. Essentially, we're committed. And the 2018 special report by the IPCC and the more recent sixth assessment lay out starkly why every 1/10 of a degree of warming increases the severity and frequency of extreme climate and disaster risks. We also know that beyond 1.5 degrees, the risks of crossing irreversible tipping points in the climate system increases. Professor Lee gave us some examples of some of those irreversible tipping points this morning. If cutting carbon dioxide is the marathon we are running today to limit the climate emergency at the end of the century, then cutting methane and these other super climate pollutants is the sprint that we also need to be running this decade to slow warming. This is the climate emergency we're experiencing today. We have to slow down the rate of warming. And this brings me to my second point. Nearly half of today's warming is from greenhouse gases, is from the gases, the superclimate pollutants other than carbon dioxide. So by superclimate pollutants, I mean methane, It's the ground level ozone smog, some of what we were seeing from fluorinated gases, and nitrous oxide. There's also black carbon soot, which isn't a greenhouse gas, but a particle that both contributes to warming and is a major air pollutant, a major constituent of that particle matter, that 2.5 particles that are causing such disease and premature mortality. So these pollutants are tens to thousands of times more potent than CO2 at trapping heat in our atmosphere. And the good news is that most of them are short-lived, meaning they only last for days to 15 years in the atmosphere. So if carbon dioxide is the slow burner, think of methane and the other superclimate pollutants as a blowtorch that together are bringing our climate to a boil. According to the IPCC, carbon dioxide emissions are contributing about 0.8 degrees of present warming. These other superclimate pollutants are contributing a similar level of warming, and here's the after-lunch test. But that alone adds up to over 1.5, you might be thinking. And you're right. In addition to greenhouse gases, human activity creates particle pollution or aerosols like we just saw. And while some of these contribute to warming, like black carbon, others, like these sulfate aerosols, are reflective and have a cooling effect. And it's this cooling effect from these reflective aerosols that is masking some of the warming from these other greenhouse gases. And so we're not feeling the full effect of this blanket that Ram described this morning. And the main source of these cooling aerosols is the burning of fossil fuels. This means as we run the marathon to cut carbon dioxide by transitioning our economies, which we must, there will be less of these cooling aerosols and more warming will be unmasked, accelerating the rate of warming at the same time as we need it to be going down. Which brings me to my third point. We have to tackle both of these climate emergencies, the climate emergency we are experiencing today and the end of century climate emergency. And to do this, we need our leaders and institutions. I'm a scientist. I like to think I have power. I don't. To take action and make deep cuts to both carbon dioxide and these other super climate pollutants. We can and we must bend down the temperature curve as soon and as quickly as possible to stay within the limits of the capacities of human and natural systems to adapt. The sprint to cut methane and the other super climate pollutants is the best way we know to slow warming in the near term, while the marathon to phase out fossil fuels is the only way to limit warming in the longer term. Both of these strategies are essential, they are complementary, and they are not interchangeable. Cutting CO2 faster won't slow warming in the near term because of this sulfate unmasking effect. At the same time, if we only were to focus on cutting methane and the other super climate pollutants without stopping CO2 emissions, that would lock in long-term warming. This is why we are in a dual race, two races at the same time, a sprint and a marathon. And the good news is that there are many mitigation options available that are low cost. We have renewable energy from solar and wind, plumbing essentially, plugging the leak from methane in the oil and gas sector, and using the Montreal Protocol that Ram alluded to this morning to speed a transition to energy efficient and climate-friendly cooling. The barriers to access are generally not a question of science or knowledge, but the laws and the policies that govern who gets to pollute and who pays for the impacts of that pollution. Thank you.
Thank you very much for informing us of the importance of the regulating, stopping the short-lived the climate forces as well as CO2 emissions as soon as possible. Thank you very much. And COP28, in fact, made a meaningful progress on the controlling the methane emissions. So this nicely leads into our next speaker, which will talk about methane, the climate leaks. Our speaker will be Orion Gustafsson, a member of PIS, Stockholm University.
Thank you. I'm honored and happy to have the opportunity to contribute to here. And I'm very grateful, deeply grateful to the organizers and the facilitators and all the other participants in this interdisciplinary summit. It's not only interdisciplinary, what's also impressive and quite unusual is that it's the stretching across many different sectors of society. And I think that's exactly what it takes for a real transition into sustainable and climate resilient society, which is a key message in the protocol that is drafted for this conference. I've been asked to talk about methane and climate. Methane is a powerful greenhouse gas. It has only a 9-year residence time in the atmosphere, and the continuing releases of methane to the atmosphere now makes it accountable for 1/3 of the global warming that we're experiencing right now. Deep reductions in methane by 2030 is an absolute requirement to lower peak warming, to reduce the risk for climate overshoot and to reduce the extent of climate overshoot, and also to lower our reliance in the future or now on mechanisms to catch CO2 from the atmosphere, which is a very large technological challenge to do on a global scale. There are signs of worry with methane. It's increasing in the atmosphere still now, and the increase seems to be accelerating. There are also signs of hope. It seems like we are gathering to also, in many programs, to forcefully mitigate anthropogenic emissions of methane. I'd like to be clear from the onset here that cutting methane this decade is essential if you are going to honor the 1.5 or even the 2-degree target, which in a sense we can read as a promise to coming generations. It is not enough to cut methane, as Gabrielle just mentioned too. We must also cut other short-lived climate pollutants and carbon dioxide. And the way I think all of us here see it, it is the only way for us to prevent the suffering for humanity from the climate catastrophe. Methane matters. It is a very important greenhouse gas. It's important, this factor, that it is relatively short-lived in the atmosphere. That is the sort of the window of opportunity to limit warming to the climate targets and thus avoid passing important climate thresholds. It might be interesting to know that the methane that's being emitted to the atmosphere is about half-half from natural sources and from anthropogenic sources, and that an estimated more than 60% of the methane emissions comes from the tropical region. But the uncertainties regarding the sources is very large. But we certainly know enough to do something about the anthropogenic sources. There are signs of this climate-enhancing feedback of increasing releases from tropical wetlands to Arctic permafrost. I'll talk a little bit about that. The Global Sustainability Research Program, Future Earth, together with the World Climate Research Program and the Earth League, is in recent years putting out an important document which comes out with a higher frequency than the IPCC reports, which are of course extremely essential. This annual report presents 10 new insights in climate science of large value for climate policy. A key insight last year was on the climate overshoot. Science is there to show that it's fast becoming inevitable and that it's absolutely essential to limit climate overshoot. One of the insights that we're working on this year is on these soaring methane levels and on different aspects of that, such as underestimation of both anthropogenic and natural emissions and inadequate regulations. In fact, it's only 16% of anthropogenic methane emissions that fall under any type of regulation. These new insights is launched annually at the COPs by the UNFCCC president, so it has some impact. Okay, but you might ask, so if we miss the targets and have climate overshoot, does it really matter if we then swing back at net zero fossil and we're able to do this air capture of CO2 and get us back down? If we look at these graphics to the left there, which is in an editor from the editor in Nature Geoscience about last year, it illustrates that it does matter. Well, I'm going to talk about that it matters, but what it does illustrate is the lower curve there in the lower panel shows that to honor 1.5 degrees, we have to have massive reductions of emissions of all greenhouse gases from now on. If we don't do that, but if we wait some years, the blue and the red curves there in the lower panel, and then have rapid reductions to net zero fossil, you see in the top one, we will have climate overshoot. And then to bend the curve later at in some unknown place above the climate target takes these negative emissions, continuous removal of CO2 from the atmosphere. These are very costly techniques. They are not really at place and haven't been shown at scale yet. So we shouldn't put too much hope into that. Better would be to mitigate now. When we reach this space beyond these climate targets, which are there because they also correspond to thresholds in the climate and Earth system, we enter unknown territory of Earth system functionality and unknown consequences for humanity. So there are many risks with climate overshoot. One is on irreversibility. So even a temporary climate overshoot, if we are to then press it down to 1.5 degrees over the coming century or so, we might during that time have irreversible effects, such as that the Amazon might reach a point where all of it by itself will disappear. We might have unstoppable melting of glaciers in Antarctica and Greenland, slowdown of the global ocean circulation, and a self-enhancing release of methane from wetlands and permafrost. So the methane levels are soaring. The methane levels in the atmosphere has increased since the Industrial Revolution, quite substantially. But then you see here that around year 2000, it reached some kind of steady state, which lasted for 7 or 8 years, maybe a decade, and then it started to increase again. The worrisome thing is that whereas we had sort of the concave increase up to that point, we now have a convex increase. So the increase is accelerating, and that's what we call the soaring methane. Same thing is shown in this blue graph here. That's the methane concentration in the atmosphere, increasing rapidly. The red one is of a sort of a personality of the methane that is there. The carbon-13 to carbon-12 isotopic composition. We don't need to get into what an isotope is. Think about it as a fingerprint of the sources of the methane. And it's decreasing rapidly in the recent decade. There's an isotope plunge, we call it. And the right one shows this on a longer time horizon. You see that before the Industrial Revolution was around -49, and then it's been increasing ever since to a peak some 7, 8 years ago or something like that. When we have a rapid shift, a regime shift in the isotopic composition of atmospheric methane. It's a big change. What's going on? What is behind this changing emissions that is reflected? Well, a decreasing isotopic composition of methane in the atmosphere signals that it's no longer the relative increase in fossil fuel contributions, but now there is a microbial source of methane that is overshadowing that. There could be many sources. It could be anthropogenic sources, such as rice paddies, wastewater systems. Definitely tropical wetlands is a big source. I'm going to illustrate this with the permafrost around the Arctic. This is an enormous pool of reduced carbon, the largest pool of reduced carbon on the Earth's surface. It holds as much carbon as 300 times the carbon in the methane in the atmosphere, and it's thawing rapidly. The Arctic has an amplified warming. In the context of the Paris Treaty, I try to illustrate with the graph to the right here. The gray part of those bar graphs is this carbon emission budget that remains if you're going to honor the Paris Treaty. The green fields there is what permafrost scientists estimate will be released from thawing permafrost this century. So even if we honor all the commitments in the nationally determined contribution and push them down so we reach the Paris Treaty, we are going to climate overshoot. That's because of that single feedback. And on top of that, I added red there, is this permafrost underneath the ocean in the Arctic, the subsea permafrost, which is even less well understood, and its potential for collapsing methane hindrace. What we're talking about is a self-enhancing feedback between amplified Arctic warming and accelerating release of methane from thawing permafrost. To illustrate, if we reach 2-degree warming, estimates are that greenhouse gas release from thawing land permafrost this century will be of the same scale as emissions from the entire European Union. We're triggering that release. Now I'm going to talk very briefly about subsea permafrost. So we've been pulling together based on a lot of expeditions we've been to in the Russian Arctic and across the Arctic, and from other researchers to methane in surface seawater. And it's elevated relative to what it should be if it was only equilibrated with the atmosphere. And it's particularly elevated in the world's largest continental shelf sea, the very shallow East Siberian Arctic Ocean, which is also where we have subsea permafrost. So we think there's a link. So to the right here, you see that over this very large scale, it's the world's largest coastal seas. There is methane levels is 10 to 100 times that what you would expect from atmospheric equilibration. When we go back there and we do drilling 50 meters down into the ocean bottom and on nearby land, these two systems were similar before the sea level rise. Both started about minus 18. The one that's now under warming seawater has reached 0. So it's thawing, and it's thawing much quicker than land permafrost. The subsea permafrost is more vulnerable than the land permafrost, but it's the one that's mostly discussed. There's good news and hope, and it is the methane mitigation initiatives that are there. The Global Methane Pledge is a very important one, proposed by President Biden of the US and President Ursula von der Leyen from the EU, but many, many joining. And the promise is that we're going to cut global methane by 30% by 2030. And it will shave off as much as 0.2 to 0.3 degree warming. And that's a lot. And we would like to get everyone on board. We're in this together. We have to work together. The way it's going to happen is largely through fossil fuel. Methane release from fossil fuel reduction, we're going to stop. There's good economy in that. Those are really low-hanging fruits. But it's also possible to reduce methane release from waste in agriculture. Mitigating methane is actually quite cost-effective. Leaky gas pipes and from production facilities and so on, if you don't lose that, that's a commodity. That's an economic value. So it should be doable to do that. There are also co-benefits between climate, many aspects of human health, and for food production. Mitigating methane, a doable thing. Final slide here, just a few messages. Climate overshoot and methane. But to face it, we're about to miss these targets. The way we're going now. We'll get into climate overshoot then. That would demand enormous CO2 capture programs. I don't know exactly how they will happen. So better would be to try to mitigate now. We have to adapt and prepare for that scenario too. We have to do everything at once. The thresholds with the climate that are passed in the Earth climate system with climate overshoot some of them are irreversible. So those that we will have to live with for a very long time. Methane mitigation is a low-hanging fruit. The urgency is now. And as the protocol says, there is a need for speed. We have to act now, and we do have a good job to do. And I was quite inspired, I must say, by the real decision makers that spoken here earlier today, that shows that there are programs, there's real action happening. So I think there's hope, but I think we should do what we can. Thank you very much for your attention.
Thank you very much. It's very sobering to hear that the seabed permafrost is much more vulnerable than the land permafrost methane release. So the world needs to act very fast on regulating this methane release. Now, our next speaker will be Andrew Haynes, Lancet Commission, London, who will speak on the pathways to a healthy net zero future. You have the floor.
Dear colleagues, it's a great pleasure and a privilege for me to say a few words about a more positive message about the future. I'm a medical doctor. I trained as a medical doctor for many years, been concerned about the effects of climate change on human health, the potentially catastrophic effects. But what I want to talk about today is the other side of that coin, which is the health benefits of moving rapidly towards a net zero future, both in terms of adaptation and mitigation. And I'm going to focus particularly on some of the work we've been doing through this commission, which is co-chaired by Joy Fumafi and Helen Clark, who you will know, no doubt, which is about developing better evidence to direct us towards a healthy net zero future. And as we've already heard, Jos presented the works on air pollution from fossil fuel burning. There are big potential health benefits, and these are in addition to the benefits of preventing dangerous climate change. They're also quite near term, so they occur over coming years and sometimes decades as well. So it's not just air pollution, of course. Our transport systems are largely dysfunctional in as much as they encourage physical inactivity, or they make it difficult to undertake adequate levels of physical activity. And nearly 4 million deaths a year have been linked to physical inactivity. It's a risk factor for diabetes, heart disease, and many other conditions. And then the food system, as we've already heard, is also causing a lot of ill health right now. And the Lancet Commission a few years ago reminded us that if we could move towards what they called a planetary health diet, which was a much more emphasis on adequate consumption of fruit, vegetables, other plant-based foods, we could potentially prevent over 10 million deaths annually by shifting to these healthier diets over coming decades. And also, of course, reduce the environmental impact of the food system, which is the major driver of biodiversity loss, of course, but also contributes very substantially to climate change. Now, this slide has already been essentially described because it really just reminds us of the inequalities in emissions. And it shows us that the top 10% of emitters are responsible for nearly 50% of emissions. But I want to make an additional point here, and that is that those people who have been responsible for very little of the emissions are also the most vulnerable to the effects of climate change, but they're also those people who suffer from inadequate health care. So when thinking about the future, we need to think about how to scale up universal access to affordable health care. But remember that the healthcare system itself contributes 4 to 5% of global greenhouse gas emissions. And about 60% of those emissions come from the supply chain. So we can't just have a healthcare system which is based on the one we have in highly developed countries today. I'm not sure they are highly developed, but high income countries anyway. In the States, for example, it's nearly 9% of greenhouse gas emissions. So we have to have a different conceptualization of health. Health has to be built in to our societal priorities, not just through the healthcare system, but also through policies that can promote and support health and also take us towards a more sustainable future. So very, very briefly, our work in the Pathfinder review synthesized evidence from as many countries as we could find. We had to harmonize the evidence, which took a long, long time. We had to screen about 7,000 papers, something of that order. And I think one of the challenges is that science, the synthesis of scientific results is becoming increasingly important for the future. but we're confronted with a massive increase in the sheer volume of scientific evidence, and we can't keep pace with it. So our review is already out of date. And we need to develop different approaches, probably using machine learning, which we're exploring at the moment, to rapidly synthesize research evidence as it comes on stream. Now, most of the evidence we found was modeled rather than implemented. What we're really interested in is implementation. What happens when you actually implement change on the ground? Most of the evidence is from modeling studies, which are important in as much as they give us the direction for the future. And I won't go into detail this slide, but essentially what we found was there were 200 unique actions which reduced greenhouse gas emissions and improved health, where there were metrics measuring both greenhouse gas emissions and health outcomes. Some of these affected multiple outcomes, so that's why there are more than that on this slide. And you can see that they range from buildings, cook stoves, multi-sectoral policies, electricity, food and agriculture, transportation, and so on, as you'd expect. There are some sectors that are underrepresented, like waste, for example. We know that there are benefits from different waste disposal approaches, water, sanitation, and so on. They were underrepresented in the literature that we found. And so we created these two metrics, one of which we called mitigation intensity, which gives you the number of tons of CO2 equivalent which can be mitigated by a particular policy in a particular location, a particular context. So you probably can't see the detail here, but essentially this is the kilotons, the thousands of tons in terms of per 100,000 of population. And on the right, you can see the health co-benefit intensity, which is the health benefit you get from mitigating along this pathway. And without going into detail, the first thing that strikes you is a lot of variation. So a lot of it depends on context. What is the background level of air pollution? What is the background level of greenhouse gas emissions? What diets are people consuming? What is their background level of physical activity? But the good news story is that there are big reductions in greenhouse gas emissions from many of these strategies. And through a judicious combination of different strategies, we can achieve big health benefits as well as big reductions in greenhouse gas emissions. So a lot of it's about tailoring the right strategy to the right context. And if you want to know more about the detail, there's this climate and health evidence bank that we've created, which is open access, which you can look at the modeling studies, the evidence that we've brought together, and also the case studies of implemented action. And I want to just spend my concluding minutes on just describing a few case studies, because I think case studies of implemented actions are often much more compelling than the kind of rather abstract figures from modeling studies. And so this is one of them that we found. This is in the US from renewable portfolio standards, transitioning from coal and natural gas to renewables in the US. And it documented nearly 150 megatons of CO2 emissions avoided in 2015 alone due to an increase in solar and wind power. And that was estimated to prevent between 3,000 and 13,000 premature deaths. So that's a nice example of a win-win strategy. We also know that cook stoves are very important as a public health measure. Clean cook stoves, over 2 billion people cook using these inefficient and poorly ventilated stoves. They cause probably about 3 million deaths annually. They're variable estimates, but certainly many millions of deaths. So the best way to tackle this, of course, is provide clean electricity from renewable sources. That's not always feasible at the moment. So you can also use clean fuels such as ethanol and LPG as a transition to reduce household air pollution. And this is a major killer for women and children, including a risk factor for childhood pneumonia. Also reduces a lot of black carbon, of course, and it contributes to deforestation. In cities, there are many, many strategies that can be enacted. This is a nice case study from Buenos Aires in Argentina, the More Bikes, Less Emissions program in Buenos Aires, and they estimated 12,000 tons of CO2 emissions avoided through an increase in bicycle trips, and also improvements in health, reductions in people killed on the road. They created safe cycling and walking. So these active transport strategies can improve health through increased physical activity, reduced injuries, and of course reduced air pollution as well. And what you need is integrated strategies, integrate active travel with public transport. In Australia, we came across a very interesting study where they randomized low-income homes in Victoria and Australia, and they upgraded them, but using insulation. They led to warmer homes, reduced breathlessness, as people reported. They also reported better mental health, reduced healthcare costs. In fact, the costs of this retrofitting actually paid it was paid for very much by reduction in healthcare costs, and also, as you can see, reductions in CO2 equivalents. And then nature-based solutions, we've heard something about those as well, and this is just another example. Urban trees can bring health benefits. So this study documented the ecosystem services of 170 million urban trees in California, and showing the reductions in greenhouse gas emissions, but also because they store CO2, they reduced air pollution. There's an increased deposition of some pollutants on the leaves of trees. But you have to plant the right trees, because if you plant trees that are allergenic, you can make people's health worse. And some trees produce volatile organic compounds, which are precursors of tropospheric ozone, which of course is a greenhouse gas and also damages health. So you have to know what you're doing, but with the right policies, you can achieve benefits. And then finally, this is a nice study that was done in Indonesia. An NGO called Health in Harmony consulted the local community to find out why they were deforesting. And the answer came back to them. In many cases, they were deforesting to pay for healthcare costs because they couldn't access affordable healthcare. So what they did was to implement affordable healthcare to these forest communities and documented improvements in infant mortality, better healthcare coverage, 90% fewer households relying on logging income. So you can't just prohibit deforestation, you have to understand what's driving it. Poor people don't necessarily want to deforest, but they have to in order to survive. So this is just a nice example of a win-win strategy, providing healthcare can also reduce deforestation, protect nature, and also reduce carbon emissions. And then finally, the healthcare, the dietary changes that are needed, moving particularly in high animal product consuming populations to more plant-forward diets, as they're often called. Here it's difficult to find case studies of how diets have actually been changed by policies, but we do know that there are many people living in the population today that are actually already consuming diets that are healthy and low emission. And this is one study led by my colleague Pauline Shielbeek, studying over 500,000 people in the UK, and showed that those people that had high or intermediate adherence to dietary recommendations, the so-called Eat Well diet, had a 7% reduced risk of mortality from heart disease, and also 30% lower dietary greenhouse gas emissions. Much of this from methane, of course, which ties in very well with the previous presentation. So we're also potentially able to reduce tropospheric ozone, methane as well, through this dietary change. So you can't avoid talking about the food system if you want to talk about climate change and methane. So finally, in conclusion, let me leave you with a positive message that there is a lot that we can do to reduce the risk of dangerous climate change and also capitalize on these near-term co-benefits of living in a more sustainable economy. We have to think about health as more at the center of our social policy and economic policy. It can't just be addressed by the healthcare system itself. We need systems thinking and implementation science in order to accelerate this transformational change that we've already heard about in the discussion. But importantly, we also need annual reporting, because there's a lot of greenwashing about. A lot of people are saying that they're doing great work, and I'm sure they are, but it's not always easy to find the evidence for that. So we actually need transparency, we need good metrics, we need measurements of greenhouse gas emissions, measurements of health exposures or benefits, and we need regular reporting. We need to support mutual learning, because none of us have got all the answers. The only way we can go forward is by learning from each other and sharing the opportunities that are there to learn from each other. And I think communicating positive messages is really important. We also know that just telling people that we're on a catastrophic road to hell is not going to change behavior. And what we need is to create a positive vision of a kind of society and a world in which people actually want to live, and show them the way in which we can get there, improving health, stabilizing the climate, protecting nature. Thank you very much.
We have just been introduced to a new word, not just a just transition, but just and healthy transition. So this is the first time that we record just and healthy transition. And I believe that you made a very important point of introducing, one of the points you made is the indoor cooking pollution, indoor air pollution due to this traditional use of biomass for cooking. And in fact, a number of people, mostly also in the household, housewives killed by that very inefficient and polluting energy sources. Our next speaker will talk about the nature-based solution, and Virgilio Biana, member of PASS in Brazil. Virgilio.
Could I have the slide? Well, good afternoon, everybody. It's a pleasure to be again here with all of you. And it's also an honor to speak after Andy Haynes, who spoke so eloquently about health and climate. We're going to be talking about nature-based solutions with a people-centered focus. And I'll be focusing also on the side of adaptation to this equation. I come from FAS, Foundation for Amazon Sustainability, which is based in Brazil, in Manaus. This is a real picture that happened last week. We are experiencing a huge flood, a record flood in southern Brazil. You might have seen in the news. So I think we're in an era of adaptation. I think that image speaks by itself. This is currently happening right now. We have in southern Brazil today, just read in the news, 600,000 people homeless and 2 million people affected heavily by this flood, which was an all-time record by many, many times. So lots of damage, lots of economic impacts on agriculture, lots of human suffering, lots of death. So it's the first message I'd like to share with you is this dramatic situation that is happening, not only in southern Brazil, but in many places around the world. But these images illustrate this. Since my topic here is nature-based solutions, I'll just bring you the image of land use change. Imagine that this landscape was completely covered by forests. This is tropical rainforest, not the Amazon, the Atlantic rainforests of southern Brazil. And this is what happened with the flood. Look at this. So imagine this building here, 6 meters of water probably would go all the way to the ceiling. This is the amount of water that flooded these towns. And why did that happen? Well, first of all, we had an extreme rainfall in terms of volume. But secondly, we have a land use system which is the opposite of a sponge that our friend from China was talking about. The IPCC predictions show that in this area of southern Brazil, northern Argentina, there will be an increase in total rainfall and extreme events. That's the scenario. So this is likely to increase in the future. And that brings the challenge of rethinking agricultural production systems that, again, do the opposite of this sponge. As we have heavy machinery, as we use a lot of chemical fertilizers, we reduce the capacity of soils to absorb water. And that also results in a lot of erosion that fills the rivers and lakes and so on. So there's a big agenda in terms of nature-based solutions to change agricultural systems deeply. One approach that we have been working on for the last several years is labor-intensive, because we not only have a climate crisis, but also we have an inequality crisis with lots of poverty. So labor-intensive, pro-poor nature restoration can be a way of linking these two agendas, the social inequality agenda with the climate agenda. In this picture, you see on the right-hand side an agroforestry system with acai palm, with cacao for chocolate and coffee and several other crops, which is very different from this landscape. So you can restore carbon and you can recover biodiversity and also improve working conditions. Working in the shade is much better than under sun in the tropics. Another image that I'd like to bring to you is one that Marcelo knows, who's been there. This is the Negro River, a tributary to the Negro River. On the left-hand side is the drought that we had, a record drought last year, all-time record, since 1906, that we have measurement of the river level. On the right-hand side is the sort of a normal situation. And we had a record flood the year before. So these extremes are there. This is not anything unique, but I'd like to share with you what's the solution, what's the approach. But first of all, it's not only to bring solutions from outside, but also to engage local people and consider they're intelligent, they're clever, they have a lot of ideas, and they have to be engaged in decision-making using their knowledge, building on youth. This is a meeting of youth leaders discussing climate change solutions, and also value indigenous knowledge, which is different from local knowledge. There's a lot of expertise of indigenous peoples, and here we have a participation of some that we're going to share their views tomorrow. We have to consider not only nature-based solutions per se, but also consider the fact that they have to be a part of a systemic approach that considers all the 17 SDGs, which are represented in the outer circle, and at the core, education and bioeconomy. That's the approach that has been developed by organizations such as FAST. I'd like now to bring a sort of more of an international picture here. There is a diplomatic mantra, which is common but differentiated responsibilities. So when we discuss adaptation, who is responsible? It's basically the US, 40% of total historic emissions, the European Union, 29%. Altogether, the global north account for 92%. And this is a big elephant in the room. I think we have an issue of responsibility which is not being adequately dealt with at the international arena. This is extracted from a Lancet publication, which is there. The UN Adaptation Gap Report shows that we are falling short of the funding. So it's only 20 billion in 2021, a decrease compared to 2020, whereas there's a need of something around 10 to 20 times more of that funding. So there's an issue of global moral injustice. And there's a discussion in the protocol that is going to come out of this meeting about a moral sin. So that can be described as a moral sin. Adaptation is insufficient. This is a publication of Climate Policy Initiative. There are many elements of this. Probably one way out of this equation is to deal with the debt swap. Many of countries, and think of Africa, for example, where many of these countries have huge debt. And these debts should be compensated by the damage that has been made by pollution coming from fossil fuels from developed countries. I'd like to close with a little bit of a lighter image. Everyone has seen the movie or read about it, the Titanic, 1912. This was a very nice big ship that went from New York to Europe. And then what happened? People were there drinking wine and champagne and dancing and having a good time. And then all of a sudden there was an iceberg. The captain didn't know of this iceberg. So what happened? There was a crash and people died, right? So basically, we are in the same boat with drinking wine, here the Casina. But the difference is that we know the iceberg. The captain didn't know at the time. But we know, and every single presentation here talks about this iceberg, right? So the question is, how can we avoid this? This is, again, an image from southern Brazil just a couple of days ago. This is sort of the aftermath of this huge flood. And I think that this image is so compelling that we should make a very strong message saying that this injustice has to be dealt with in a very straight way. I think we need to invest in proper solutions to tackle this climate injustice, to tackle this moral sin, which is happening right now. And there is a very simple way of dealing with this, which is to increase funding. If we look at the budget that is being allocated to wars in many areas of the world, is just ridiculous what is being done at this time. So my final message is that we should invest in nature-based solutions. It's not a panacea. We, again, heard from our colleague from China many success stories. These are solutions that are available. They don't require new technologies, basically something that people know, indigenous people know. We can engage a lot of people thinking, in the case of Africa, where there is huge drought and a lot of solutions could be implemented there without much funding. So I'd like to leave you with this message. Thank you.
Thank you.
Thank you very much for the very insightful presentation. I can summarize your statement, your presentation as a nature-based solution. Nature-based solution is a people-based solution. So this nicely links to the next speaker. We'll talk about the human rights issues, Romania Piccolotti, the IGSD, USA and Argentina. You have the floor.
Thank you. I know I am the last one before coffee break. So maybe we can move a little bit and I will try to be as short as possible. So first, my gratitude to Pope Francis, obviously, for his unwavering critical guidance amidst the climate emergency. Cardinal Thorson, Sir Alford, Professor Von Braun, thank you for this joint summit. Cannot be more opportune, I will say. And Professor Ramanathan and Marcelo Suarez Orozco, thank you a lot. I think this is really a good gathering, and the whole team behind this gathering for the work. So I'm here today to present a framework for policy and investment guidance that we have been working on. That is linked to human rights, basically, and it's called the Human Rights to Resilience. So this is the era of resilience, as we know, and have been said again and again here, as emphasized by the works of this academy and the IPCC, humanity is swiftly departing from the familiar conditions that have nurtured civilization. So now we find ourselves in the era of resilience, facing an unparalleled challenge, which is the imperative to stabilize the climate system to ensure the survival of humankind collectively without leaving anyone behind. So how do we do this? And I think a fundamental principle emerges strongly, which is that every human being has the right to resilience. And so this prompts critical questions. Can conventional approaches effectively address this monumental challenge? And I think a little bit our colleagues before that addressed the sponge natural-based solutions is a way of changing approaches. how do we shield our present from ongoing climate impacts and prevent irreversible harm to our collective future? In essence, how do we ensure that our policies and financial decisions promote climate resilience for all? So as extreme weather hits us, event becomes more frequent, more intense, citizens worldwide begin to ask the question about the capacity of states and democratic governments to protect themselves from what appears to be an apocalyptic future. So obviously, climate change also poses a question to state governance. So when we were faced with this kind of before in history of events, human rights law has served as a beacon of hope and as a North Star, guiding humanity from the darkest atrocities toward a world where peace and solidarity are attainable. Human rights treaties are evolving instruments, and we do believe that it's time for recognizing the human rights to resilience, which will be essential if we're going to move forward with laws and policies and investments that can help us on this challenge. So what is the human rights to resilience? It's the right of every individual and group to access and maintain resilience, and it encompasses present and future generations. What is required to access and maintain resilience? So we think this as a challenge of time and temperature. There is very little time to deploy the measures that we need to slow the rate of warming in the near term and remain under 1.5 with limited overshoot. And we're already in a 1.2, maybe 1.3 degrees, and we are in a situation where we need to reduce the rate of warming immediately. So when we move from that scientific fact to law, the human rights to resilience imposes by virtue of the principle of due diligence and the duty of care two clear obligations on state and international financial institutions: effective mitigation and effective adaptation. And we do know, because of everything that I've said here today, that not every mitigation measure will help us with resilience, and not every adaptation measure will help us with resilience. So let's take a closer look at what the mitigation obligation means. And it means and requires implementing measures to reduce the rate of warming in the near term, to limit temperature increase to 1.5 with limited overshoot. And as Professor Dreyfus and others here had highlighted, science indicates that the only actions aimed at mitigating short-life chemical pollutants, especially methane, have a significant impact on temperature in the short term. So this is essential if we are going to commit to resilience. However, these measures, to be effective, it is imperative that they be implemented on a larger scale in the next 2 to 15 years. If we look closer, science even identified the following targets. We need to reduce global emission by 40 to 45% by 2030 relative to 2030 levels, business as usual scenarios. We need to reduce HFC's emission by 85% by 2050 relative to 2019 levels. And we need to reduce black carbon by 35% by 2050 relative to 2010 levels. So we do have a roadmap. What we do not have is a mandatory roadmap. If we look closely to the adaptation obligation, we need to invest in strengthening the resilience of the most vulnerable groups and maintaining the capacity of future generations to adapt to climate impact. So that means that the measures that we deploy today need also to protect key elements of the climate system, that without them, we know we're going to have runaway climate change, and we're going to put the future generations on a position that they will not be able to adapt. And obviously, there are tests to see if states and international financial institutions are using this human rights to resilience framework, are doing what they need to do to build resilience. And one of the tests is, for example, if you only have plans to reduce CO2, you're failing the test. You must have plans to also reduce short external pollutants at the same time. You must refrain from actions that undermine resilience, and therefore you should prioritize investment that builds and strengthens resilience, etc. Subsidize to fossil fuel will be also a very easy example of how you will be violating the human right to resilience. So these are the key components of the climate system that we need to take care of if we're going to not compromise resilience of the future generations. And how you implement this at the subnational level. Where there are three sources of methane, as everybody knows here, is energy, waste, and agriculture. Specifically, waste is a jurisdiction at subnational level, and there are technologies that can be deployed to capture this methane in landfills and then produce energy. There is a whole report on driving innovation and technology in the waste sector done by the Climate Clean Air Coalition that I encourage, subnational levels that want to move forward on reducing emissions on their methane on landfills. Obviously, air quality regulations is part of subnational level as well, and as well as building codes and that can help us reduce the need of pooling at the subnational level as well. So that will be part of the mandatory obligations, if you wish, if you use this. Now, how do we finance this? And this is the elephant in the room, has been said again and again. How do we finance resilience? So 2 years ago, we worked closely with the International Monetary Fund, and a Resilient and Sustainable Trust was put together. And last year, they were able to deploy through $3.2 billion to countries to build resilience. Then we have the Inter-American Development Bank has put together last year something called Too Good to Go to Waste, and has $372 million for methane reductions on the waste sector. Then this, the European Development Bank has around 200 million euros also for methane reductions. The World Bank, 700 million last year invested on reducing methane from rice paddies in China, and landfill reduction in Cote d'Ivoire, and Malawi as well. Then there's specific funding, obviously, in the Green Climate Fund, and they have committed around $375 million for methane reductions and short climate pollutants reduction. And the Climate and Clean Air Coalition has a specific funding for subnational governments to help them, to support them technically, but with finance too, to develop plans to reduce short climate pollutants. So all of these can help with the implementation of the Human Rights to Resilience framework. These, are slow progress in the finance world, but gives some hope. And I think there's another one that we need to explore, which is that the South has a debt, financial debt with the North, and the North has a financial debt with the South, atmospheric debt. So we need to see how we can balance this debt, to promote resilience. So maybe we can swap debt, and that can be a way to finance resilience. The conclusion is, we stand at a pivotal moment in climate emergency. Resilience must guide our actions. Subnational governments can lead the way by developing resilience plans based on the Human Rights to Resilience framework. The implementation of this plan can be supported by international financial institutions as they ensure resilience action that are rooted in science and ethics and benefit both local communities communities and the planet as a whole. I want to mention that most of these measures have local benefit. Not only you're contributing with the global resilience of the planet, but you're also have very local climate benefits on health, jobs creations, and obviously building resilience at home. Thank you.
Thank you very much. We started from the, this concludes the presentations, and we initially started from the air quality, and then we visited the methane, and then we heard about the healthy transition and NBS, and then we came to the human rights to resilience. We covered a number of topics under one session theme, air, and usually, when the sessions theme air, one would expect a certain categories of issues one would expect, but we covered a lot more than the usual items we expect. So that introduces the situation that we will have very interesting 30 minutes for discussion as a way of concluding this session on air. So the floor is now open for 30 minutes discussion. Yes, please raise your hand and identify yourself. Yes, please go ahead.
Yeah, I have a question to Governor Healy. I think most, Vittorio, who says my name, from University of Notre Dame. I think that most scientists are in clear agreement on what is the situation and what has to be done. At the same time, the political system has enormous difficulties to adapt. And I think there are two reasons, and I would like to hear from a practitioner of policy, of politics, how we can address these two issues. The one issue is, of course, that to go back to the Titanic example, we all remember that the people in the first class were treated differently than the people in the third class. They even saved all their coffers with their jewels, even if this meant that hundreds of people more had to drown in 1911. And the problem of climate justice is a problem for a large amount of international justice. As we have heard from almost everybody, a very small part of the population is responsible, 15% of the population, for 80% of the damage, and the costs are taken over by the poorest one. According to every principle of justice, it is clear that we owe them compensation. Whether this means that they also have a right to move to the other countries are more complex issues, because there is the problem to which country should they go. And you cannot simply say they can choose where they go, because this could lead to an overburdening of a country. But how can a government convince the people of the affluent countries to pay compensation, for example, or to open the borders to climate refugees, without fearing the backlash that we are seeing in many countries in the world, where populist politicians are stoking xenophobia in order to bring themselves to power. It may happen in November in the United States, as we all know. So this is the first question. And the other issue is the problem that the problem of climate justice, at least till a few years ago, was not only mainly a problem of international justice, where we do not have mechanisms within the same state to solve the issue, but also a problem of intergenerational justice. That people could say, well, but this will happen after me. Even if people have some natural interest in their children and their grandchildren's benefits, it's not that strong as the direct one. Things are, however, changing because people are becoming aware that all these negative consequences are happening much more quickly than they thought. I remember, Ram, you once explained to me that when you began to work on climate change, you thought it will hit your grandchildren. After 10 years, you understood, no, it will hit my children. And then you said, if I have a good life expectancy, it will hit me, myself. So this is changing. I see it also, for example, when I teach environmental ethics at Notre Dame. 20 years ago, when I taught a course, the evaluation was devastating. I never got that bad grades. This is a rat tyrant who wants to take away our SUVs, etc., etc. Now, the people are afraid. The students are afraid, have also mental problems, because they know they will go through that. The strange thing, however, is that they have been so accustomed to an affluent lifestyle in the last 20 years that even if they know that this cannot go on like that, they are not able to even muster the energy to try to reduce, for example, their meat consumption, their flights, etc. And how do we address that? I mean, I don't see our students being able to transform their cognitive process, which has happened in the last 10 years, into behavioral choices. So I would like to hear from a practicing politician what we can do.
Thank you very much. I would like to invite two more hands, and then I'll give the floor to Governor Healy. I recognize you. Just two more questions, and then you will have the floor.
Thank you, Chair. Two quick observations. The African perspective on the scheme. The first point about air quality, I want to raise attention to the audience here that the decarbonization of the transportation system in the northern world would likely lead to an increase of the carbonization process of our transport system in the south. If we take the ozone fight 20 years ago, most of the fridge which was used in Europe and banned because of new legal system ends up in the market in Africa. So as we decarbonize in Europe, we carbonize in Africa. And I'm afraid with the new decarbonization process, with Tesla electric engines being protracted in the northern world, the old car will not end up on destruction. They will end up to Africa. And if you take the latest NDCs, the latest reports, the greenhouse gas contribution from transport system has gone from 7 to 10% to 12 to 15% because of the increase of number of vehicles, but also because of the increase in imported second-hand cars. The second point is challenging my friend Virgil. We always have semantic discussions, common and shared responsibility. I really have problems with that personally. And I will take the analogy of Titanic to challenge you on that. For me as an African, we are not on the same boat. We are on the same storm. We are under the same storm, climate change, all those challenges. But the fact of having resources to deal with climate extremes, example of Haiti, after some storm, hundreds of people die. The same storm continued to Florida, 2 people die. We are not under the same boat. We are under the same storm. And by bringing this perspective, we can reflect more on how we differentiate the impact of climate before we differentiate the responsibility of people on climate change. Thank you, Chair.
Thank you very much. Chancellor Sanchez Sorondo, and then Governor Healy. Chancellor.
Thank you. I want to ask a general question for all people, because I don't hear nothing about this. What is the pollution that produced the wars that we have today? What are the estimation, the proportion of the pollution that produced the wars that we have today, especially Ukraine, Russia, but also Palestine dispute? Thank you.
Right, one more question, and then Governor Healy. Yes, yeah. All right, okay. Governor? Yeah, you are invited. Yes, please respond.
Well, thank you. I'll respond to the couple of questions that were posed. I guess I'd start with a comment about young people. In my experience, it's young people that express the greatest anxiety and the greatest frustration at the world we have left for them. They are the ones who protest most often in my office and at events. It's the climate activists. I think for me, I look at it as an opportunity to harness that energy. I think that people, in order to be harnessed, they must be given hope. They must be shown, and this is where I benefit from policymakers and others who can point to a politician like me and say, these are the things that must be done. Then I can work with my team on what must be done and then present that to young people. It's why we have this climate workforce, because I need 12, 13, 14, 15, 16-year-olds who are so distressed about what's happening to have hope and then have agency. So have a career pathway where they learn to be an electrician, where they learn how to install a wind turbine, where they learn how to build nature-based solutions. I think that's important, and I think it's young people who will continue to fuel and force this and force politicians hold us accountable. I also think it's important to meet young people where they are. A couple of weeks ago, I was with 6-year-olds planting trees, okay? And you use that as an opportunity to talk about the importance of what we're doing with carbon sequestration and why trees matter. And so I think education is also key, which gets to the first question you posed. And I wish I had a better answer. I find myself of a few minds about this, and it bears a much longer discussion. I come from America, and people understand a little bit about what's going on in our country right now, and it's not encouraging. I so much appreciate the federal partnership of President Biden, because no one has done more for climate than President Biden and his administration. And that has gone to the benefit of states and localities. But my view of this is that it comes back to doing what you can from where you are. And the comments about local action, to me, really resonate, because I, for example, am able to do things in Massachusetts. Maybe they give an example to other states, to other cities, to other places. Everybody has to be their own laboratory. And what I learned from all of you is that actually these things they may be incremental, but they are nevertheless something. And so how do you make the most of where you are and what tools you have at your disposal as a politician? For me, it is in my rulemaking, it is through the work of my executive agencies, and it is through the budget. Last evening, when I returned to my room, I was barraged by a series of texts and calls from some landowners who were very upset because storms had been washing away the sand on one of our coastlines. And the community members want us to pay to replace the sand. And this is the real stuff that we deal with. And so, you know, for me, it's about having the conversations, educating about why that's foolish, and we're not going to do that, and withholding funds. Others have given funds to build walls and do other things. I'm not going to. I'm going to go back and learn a lot more and think a lot more about sponges and a whole host of things. But that's my power. Ultimately, for all of us, I think we have to focus, though, on education, because I believe that in the good of humanity, that everywhere within every person is good. And sometimes they are beset by misinformation, disinformation. We all have self-interest. But I think we can transcend a lot of that. Our self-interest, by the way, should be in addressing climate. But I think we can address a lot of that through education and making the connection that has to be made, and it's on people like me to do a better job of articulating exactly why it is these actions have led to high asthma rates, or more trips to the emergency room, or whatever else is happening in terms of the destruction of coastline, for example. So that's my hope through all of this. It's through education, and it's through bringing people along, winning hearts and minds, which I think you do through hope and through agency. Thank you.
To the Chancellor Sanchez question on the effect of war on the pollution. Okay, I recognize Kimutai and then Vienna. So first Kimutai and then Vienna.
I'm using the wrong button. I think the comment that I wanted to make is one on overshoot. And
And I'm really just reacting to the presentation made by Ojan and Gabrielle. And I mean, every time it's really important when we're talking about overshoot, even just being careful on using the word overshoot, because you're already saying, because overshoot means surpassing a target and then coming back, right? But I think you should start by saying, what are the risks of actually surpassing that target is where the big conversations should start. And that is to do with the dynamics of overshoot, right? So what are, sorry, dynamics of surpassing the target. So what happens when we pass 1.5 or we pass 2 degrees? For how long are we gonna stay up there? Are we gonna stay, then come back, then go back, then do, you know, like what are the sort of the dynamics after that? And of course, at the center of that is the irreversibility, right? Which systems are likely to tip? Because, you know, when, and this is a conversation that we don't want to have, because if, for example, you talk to a humanitarian system and you say, how ready are humanitarian operations to surpassing a target? They're not ready. They don't know how they'll scale the operations. They don't know how they'll scale the financing to respond to the crisis beyond that target. And so it's really about what happens when you surpass the target. What are the sort of the cascading risks that's going to happen to every ecosystem? And of course, we understand that our systems are very interconnected, right? So there's been a lot of issues around that. So even as we talk about thinking that we can surpass a target, we can surpass 1.5 or 2 degrees, and we think that we can deploy all these technologies, which are very inevitable, actually. We have to deploy to come back. We should think about what are the feasibilities of these technologies. So it's really likely that we might surpass these targets and are not likely to come back at all. Because, I mean, it's really from experience that it's been very difficult to stay below. So thinking that we will go above it and all of a sudden there's magic that we'll do things and come below is really the conversation that we should have more often. And so I'm really tying that up to what Romana was explaining about human rights, right? So we should start looking at how we need to have laws that are binding, or agreements that are binding, or decisions that are binding. So that it's not about having this Paris agreement, agreements that are not legally binding at all. I mean, there's issues of reporting. We know that very clearly, like there's a lot of cheat happening, like we're not sure who's doing what's happening. There's a lot of greenwashing especially by fossil majors, right? And so then it has to be really things that are binding. We have, I'm starting to be very much in the science that I do to support some of the climate litigation cases. Because to me, I think that's a more just way of doing things. Because we are saying, if you're doing this much, you actually have responsibility to compensate the particular impacts that are experienced in this part of the world. And I think for oil majors, if you tell them that actually you need to pay, or there should be money, or there should be financial cost implication of your actions, then they are likely to take action. But if it's just about talk and saying that, oh, it's really important for us to cut emissions because people are being impacted, I don't think we're gonna get anywhere. We're gonna surpass 2 degrees, 3 degrees, and impacts will just continue escalating. Yeah.
Yes, thank you very much. Just before I giving floor to our next intervener, this overshoot and coming back down to 1.5 only exists in the scenario world, and is really the I call it is just kind of fantasy, and we really need to see the what's the reality behind the scenario. The modelers they introduced this concept of overshoot, and they were more or less asked to present scenarios for the 1.5 global warming by the end of 2100. And the only way possible to derive that conclusion is through this overshoot passage. And then that overshoot obviously implies technologies to capture the emissions, not only the emissions occurring on site, as well as the capturing emissions stock accumulated very long time in the atmosphere. So this is really a I don't want to say it's a fascinating scenario, but it's really the scenario of the last resort. So I want to recognize Vienna, and then gentleman in front of me, yeah, Vienna.
Responsibilities. Yes, I think we should have common and differentiated responsibilities. We should have, but we actually don't. And we don't share the same burden. And think of a flood in Bangladesh and a flood in Germany. I happen to have visited a flood in a region that I can't pronounce very well. My German is not that good. It's Erfstadt in southern Germany a couple of years ago that killed about 200 people. And I went there a couple of weeks after, and there was this huge investment, if I'm not mistaken, 30 billion euros to restore that small watershed. And a similar flood happened in Bangladesh, and the amount of resources that was available was just completely different. So I think the burden is quite different. People don't have bank accounts in some places, whereas others have not only bank accounts, but with money in their bank accounts. So I do share a similar view. And I think the fact that we have a governor from Massachusetts and a governor from Kenya would be interesting to have a dialogue and see maybe we could have subnational arrangements that go beyond the sort of the diplomatic limits that federal governments have, as just a food for thought. And as far as Marcelo's question about the war, the emissions, I just looked it up. The war in Ukraine has an emission of about 77 million tons, so that's less than 1% of total global emissions. But if we look at the amount of money that has been diverted to the war, and these are just quick numbers that I got here in a quick research, it's $100 billion to Ukraine and about 94 billion to Israel. So altogether, big numbers, 200 billion. Whereas the amount of money that was invested in the adaptation fund is around 50 million by US, 60 million by Germany, 20 million by Spain, and so on and so forth. So it's around 200 times less to adaptation compared to military spending. And these are just two wars. Now there are more wars going on, and I didn't have the number for Russia, that Russia is also spending lots of money in that. But I think there's a big issue that we probably don't have time to go into that might deserve a different conversation. But I think we have to look at the ethics that we have currently been practicing. I think this, I mean, just to respond to Marcelo on the issue of wars. And Pope Francis is very outspoken on the issue of peace. And I think if a part of the equation of climate change, I think, should include peace, not only for the direct emissions of military activity, but also the amount of money that is wasted in bombs and destruction. You know, we should use that to plant trees.
Thank you very much. Next intervention is colleague in the middle, please.
Thank you, Chair. I also, by way of introduction, I'm Arunabha Ghosh. I'm the CEO of the Council on Energy, Environment, and Water. But right now, I want to make my comments wearing the other hat I wear. I'm the Vice Chair of the UN Committee for Development Policy. So when I look at developing countries across the world, and I think about overshoot, I think we are limiting our conversation about overshoot only in the context of emissions and what the science is telling us. And that is a necessary precondition for the three other conversations we need to have, the economic conversation, the social conversation, and the political conversation. So let me just submit a few thoughts before all of you. The first, on the economic conversation, we can't talk about overshoot without understanding, as you were saying, what is the different boat we are in. The different boat we're in is that actually in developing countries, you don't even know what your disaster exposure is. There is no high resolution climate risk assessment at a hyper-local level in developing countries. If you don't know what your disaster exposure is, every single extreme event that then hits you adds to what is called, in insurance terms, the protection gap. So then you will have a Swiss Re saying there are about $270 billion of damages in a single year, but about $130 billion is actually completely uninsured because you never measured it in the first place. And that then compounds the debt crisis that developing countries are under. At least 60, if not 100 countries across the world are under severe debt crisis. So if you have a 1-year drought, it's bad. Your 2-year drought, it's a pain. If you have multi-year droughts, one after the other, you basically run out of anything you can give out to farmers or whoever else as a way to tide over to the next season. This is the economic context in which the conversation is happening, which then binds countries into a completely false conversation about climate action when there is no fiscal room left at all. The second conversation we need to have is the social conversation. And I think Chancellor Marcello's comments at the outset were very, very pertinent about focus on migration, and there's a entire session, I think, day after tomorrow on it. But internal displacement, primarily in developing countries, is, of course, one part of it. Related to this is the gender dimension, because even to the extent that those, some of whom who are able to get out of a really environmentally stressed areas often are the men, and the women and the children and the elderly are left behind to then tend to the smallholder farms, etc. That then creates a further compounded social dimension, which is resource-related, localized conflicts, which then get labeled as so-called ethnic conflicts. They're actually resource. So we need to have an overshoot conversation based on the social stress. And then comes the political conversation. I think, Governor, your comments about how do you build the skills for the future are so important. Because it's not just about climate insurance. It's about enabling and empowering the communities to be able to build that future that we want them to inhabit. But that's the local political kind of offer. But there is a global political problem as well. We are sort of 30 years past the end of the Cold War, and the peace dividend is kind of over. And we are back into protectionist zones, armed conflict, capital outflow from developing countries, rather than capital inflow, as Economics 101 would teach you. That is telling you that there is very limited trust in whether politics can deliver the answer, notwithstanding leadership like yours. So I would submit that when we have the economic, social, and political conversation around overshoot, then let's see what are the solutions we can come up with on making resilient. And I really like Professor Ramanathan's framing of resilience, this 5-part framing of resilience. But at the core of it is, how do you make resilience hyper-local? How do we make debt and dealing with disaster as preconditions for development and decarbonization? And how do we invest in the capabilities of human development in order to re-inject the trust in politics at those different scales of governance that you highlighted, Governor. Thank you.
Yes. I have 4 requests for follow-up, Professor von Braun, and then gentleman in the back, and then James Pacheco and the Suarez Orozco. And we do have 10 minutes left for this session. So, Professor von Braun.
Yeah, thank you. I have 2 questions. One, and each is to 2 people. My first question is to my 2 colleagues on my left. After what we have heard this morning and this day, don't we need an implementation plan for the strategy which you have put forward? And if so, how would we get there? I'm not asking you how that should look like, but we have, I think, clarity on the what, but we don't have clarity on the how. So maybe that's too early to reflect on at this stage, but before we leave this wonderful conference on Friday, I think we should have some milestones, some pathways, some ideas on maybe plan the next workshop on it. My second question is on the water session, and it is to Sunita Narayan and to Gongjian Yu. It's nice to see China and India sitting next to each other on climate issues. I'm afraid the water session has missed a serious point. And let me exemplify it with the water castle of the Himalaya. How do you apply, Anita, your concept of augment water and your concept of sponge planet to this huge issue which will change the rivers of Asia? What's the river concept? The local concept I've understood, but what's the river concept of adaptation to climate crisis?
Yes, thank you very much. After we listen to a couple of interventions, then let me give you the floor for response. So I will invite, yes, right.
Michael Berkowitz from the University of Miami. Just maybe to tie Professor Hassel's provocation and the governor's response, and this might be a slightly more tactical, but when we look around the room, when we talk about climate risk communication, how we understand the risks that we're facing because of climate change, it's a hard risk to internalize because it happens over a long period of time, a wide geography. There's lots of reasons why we have a hard time internalizing that. And there are folks, particularly in the public health sphere, that have thought a lot about how we internalize those kind of risks, whether it's smoking, safe sex, obesity, all kinds of seatbelts, all kinds of different risks that we need to better understand. And in general, in the climate world, we don't associate with those risk communication professionals. I don't know if there's anyone here who really has spent their careers thinking about how we talk about these kind of risks. The politicians and the governor might be our best proxies in this room to tell us how people internalize the climate risk. And we're at this moment of disaggregation when, if you read the Edelman Trust Barometer, for instance, you see people have lower and lower trust of authority. The top sources for understanding climate, according to the latest Edelman Trust Barometer, were either scientists or your peers. I might ask people who have PhDs who have spent lots of time thinking about this, or John, who I go drinking with, one or the other. And so we have to begin to understand better how people come to grips with these very emotional, very long-term risk factors, whether that's social media or scientists or authority figures or politicians, and spend some real rigorous time thinking about that and bringing those people to our next convening. That might be part of the how that Ram's alluding to. Thank you.
All right, thank you very much. Let me hear from Jane Secor and then Suarez Orozco. Jane Secor, you have the floor.
Thank you. Would it be possible to have responses to those two before we go to the next two questions? I think we're going to go in so many different directions, we're losing the threads of some of these exchanges. Is that a possible friendly amendment?
Let me first give the floor to Suarez Orozco and get going back to your question. Suarez Orozco, you have the floor. You didn't ask for floor?
Yeah, thank you so much, Bridget Mohn from the Bertelsmann Foundation. I think many things are said here. It's about losing trust for the people in the different various areas. And I think it's about gaining trust by being a role model again and being reliable and responsible for what we all do. And I think it's about showing this, and I'm missing here a little bit the social media, what you were just pointing to, Michael. And I think it's as well the capability of AI enhancing young people to be part of the solution makers and the people on the ground basically chipping in to what they have learned about risk management in their local communities. So I think that is super crucial if we have a transparent implementation platform wherever this will be, and to see if we have like Google and all the other ones being in the room and they have the data. It's the same with telecommunication companies, right? They have the data, they have the risk management real time if we would let them in, and we have to guide them with basically the moral, ethical frameworks, how to use the data. But I think it's important that they understand what role they have to play within the communities where all basically serving. And as in science, and you all are not on social media, you are the role models in your science community, but we need you out there. And I think it's super important to show solutions for the people that when floodings are happening in Brazil and everywhere in the world, and we are having less and less investments instead in keep saving the populations around the world and spending it into destruction, right? Into wars. And we have more and more the communication about destruction. And it's a new goal of basically eliminating people from this planet. I think it's super crucial that we start working together with open communication and letters to show that some people have a different agenda in basically not destroying everything, but we take it serious to safeguard life. And I would invite the people here to define a communication plan after these 3 days, how we want to implement this, because I think that's super important. And everything what's happening here should be addressed to public, because they don't know what's happening and they don't know how to basically get out of this victim role and be part of the solution movement. And I think it's an invitation to join all of us. And I think media plays an important role wherever it will be. And I think COP30 would be a real goal for this, to spend a communication campaign around the world for getting science into the middle of social media for young people in the next generations.
Thank you very much. We have two specific questions put to us. One is questions about some themes presented in the water session, and then the mass strategy with regard to some concrete plans with regard to the mass strategy. So before we close this session, some responses of those two questions will be relevant. And do I miss any burning questions? Yes, please.
You raised exactly beautiful question that Sponge's planet going to answer. A river is not one line or two lines. A river is made of 1,000 or millions of small rivers that connect individual, from individual backyard to a village, a farm, a city, and to metropolitan area. When you look at the Yangtze River or Amazon River, it's made of not one river, it is a whole planet, like human body. Your blood come to here, all the way come to fingertip. Now that's the beauty of using water as a key. It is manageable, it has responsibility, it is clearly a boundary. It's different from carbon. Carbon is anywhere, untouchable, untradeable. Water is tradable. We have very mature system to manage water in any culture, particularly in those monsoon regions. Individuals know how to retain water during the monsoon season and release water during the dry season. And even the whole nation is built on managing of water. For example, China and any other countries. The whole system, the social system, is building upon management of water. That's adaptation. So adaptation is a cultural strategies, adapting the natural, whatever natural climate change or flood or anything. Now that's why I will suggest, in addition to cut carbon emissions, that's of course, that's clear, but that's the target, not the key solution. The key solution lies in water. Water connects energy, water connects biodiversity, water connects carbon. When you manage water well, you have certainly much better ecosystem. You certainly have much better carbon attraction, and certainly you have biodiversity. So that's your beautiful question. I say we have to have a unified, centralized consensus that divert so much money. We don't need so much money. I have to say, maybe only have a 10% of money that we have diverted into so-called technology. I have to tell you that hydropower is not green. Solar power is not green. Windmill is not green, because based on my immersive experience, all those so-called technology, green technology, actually messed up many things. So we have to transform, we have to change our mindset from Renaissance-based science, so-called science, which means single-minded, stratified knowledge system, into a new kind of civilization, which must be holistic, sophisticated, systematic understanding of a global system. Now that, I think, thank you so much. Thank you.
Dr. Lee, can I give a shorter reply? I think my friend from China has said it all, but if I may give a shorter reply to you. So I think the river question is critical, but as very much as Hugh has said, rivers are really about the water that flows in it. And for us in our part of the world, in my part of the world, our river today is a river of sewage in most cases. We did a book on Yamuna and we called it the Sewage Canal. Okay? We say rivers in India are dying. And one of the things that I keep telling people in India is that we'll be a generation which would have lost something and that's a river. Because a river called, in Mumbai, it was a Mithi River, is today officially a drain. A river in Ludhiana is officially a drain. A river in my city called Sahibi has disappeared and is called the Najafgarh Drain. So we are a country which is a generation which is going to lose rivers. Now, the only way to bring back the river is to make sure that it's not sewage, but water that flows in it. And for me, therefore, the challenge is two. One, reduce the abstraction from the rivers of the water and reduce the flow back of sewage into the rivers. I mean, I'm being very prosaic about this, and that's really what our reality is today. Now, how do you reduce the amount of water demand? Today, the river is soaked. I mean, every drop of the Ganga is taken away for irrigation, for drinking water, and what cities return to it is sewage. And that's the same river after river after river. So to change that paradigm, you need to do, one, harvest the water where it falls. We keep saying rain is decentralized, so is the supply for water. Catch water where it falls. Make sure that you build water security, and that's not only about augmenting water, it's also about reducing the need for water. But most importantly, as we have done this, we have found that the water story is completely incomplete unless you can treat the sewage. And that's where the question about the circular economy, looking at the sewage as a resource so that you could build an affordable system which takes the sewage, treats it, and puts it back as water. So the river story is really about the connection to civilizations, the culture of people. And I think that's what China, India, and I'm glad we're on the same page, on one thing at least. Thank you.
We passed 5 p.m. There's a lot of time for this session. We can go on this discussion, but the only problem is that we will devour our coffee break time. So we hope we not do that. I believe Professor Ramanathan and Professor Marcelo, please, you have the floor. You have a last word.
This quick response to Professor Joachim's comment. How are we going to implement? And that's going to be the topic of the discussion tomorrow's last session between 7:30 and 19. We say planetary protocol for climate change, and then there is sub-regional summits. You're going to hear from at least 5 or 6 of us on the implementation issue. I would defer that, but I just want to comment one thing on the protocol. The Secretary of State's office at the church had, at the Vatican, had a problem with the word protocol. So Chancellor Marcello and Social Sciences President Sister Helen came with the ingenious suggestion from protocol to compact. And that has been approved by the Vatican office. So it's now, from now onwards, called Planetary Compact for Climate Change Resilience. And hope all of you would sign. You're not required to sign it, but hope all of you would sign it. The signing part would take place tomorrow morning. Somebody will explain, either during the Pope, Holy Father's audience or before or after.
Yes. All right, thank you very much. Let me conclude. I come to a conclusion of this session on air. We forgot it's an air session, but we cover so many interesting topics. So we have a 30 minutes break, is that right? All right, okay, so we have a break. Thank you.
Yeah, please take your seats, please. Colleagues, please take your seats now. Okay, please sit down. This session is about food, not about coffee.
There's plenty out there.
Maybe move this so I don't catch it. Are you sure? Okay.
Dr. Chente Fan, is your PowerPoint ready or do you not use a PowerPoint? Please get it loaded so that we can start when everyone is in their seats. The PowerPoint. Dr. Chente Fan of the National Tsinghua University. You have the floor in a moment. Please, technical team, load the PowerPoint. Yeah. Switch on your microphone, then they see you and they may respond.
Oh, here we are. So they will turn the page for me.
Some clicker has to be brought.
Yeah, the clicker. Oh, okay, got it. All right. Oh, may I? Okay. Thank you, Mr. Chair, and ladies and gentlemen. Well, it's been an honor having this opportunity to be here and to share some of our experiences in promoting the public communication when we are working on the aquavoltaics development and in conflict with the possible food security issues. And yes, we all know we are facing the climate emergency, so I don't need to repeat that again. And also, after years of the efforts and subject to series of the scientific studies, and the IPCC report does produce very convincing to realize the climate emergency. On the other hand, in the political economy side, we have seen also series of the COP efforts. Then we come up with the Paris Agreement, which is legally enforceable for the participant countries. The pledge to reach this zero emission by 2050. And after the COP28, we are convinced that transitioning away from fossil fuel in energy system in a just, orderly, and equitable manner, accelerating action in this critical decade so as to achieve net zero by 2050 has been now the core for our attention. But after we've been producing or generating so many technologies and invented so many advanced technologies, when we start the deployment, we face serious challenge about the public trust. And that's the issues, I think, not just Taiwan face, other countries and all our friends here, we are facing the similar challenges. How to gain the public trust so we can deploy those, we think, the best technology to combat the climate emergency. And so I try to share with you some of our experiences in this regard. Here, for the aquavoltaic, is, I would say, just an exemplified case for all your references. Yes, when we try to promote the renewable energy, and on the other hand, we need to care about the food security. So in the long run, we believe that with the deployment of renewable energy, which could maintain the pledge goal that we could keep the temperature not over 1.5 centimeter. That could achieve the carbon neutrality and mitigate the extreme weather that might jeopardize the agricultural production. And also, for the long-term purpose, it could also reduce the threat to food supply stability. And certainly, that could ensure sufficient and safe food access globally as well. That's the long-term benefit. But how about the immediate challenges that we face? For instance, when we try to promote those aqua-voltaic, we have seen the challenges derived out of the development of renewable energy would require intensive land use. And also, that would compete directly with food crop cultivation. And also, certainly, that may limit food production and impact food security. So, it's a kind of the dilemma. And let's turn to the SDG. We understand that according to the SDG, the number 2, the principle number 2, it directly relates to the energy and the high land relevancy. And it said that we need to manage the balance between energy production and the land use to ensure both are sustainable. Yes, we all understand that. And also, on the other hand, it also mentioned that we need to ensure energy development sustain agricultural integrity, because that will not only increase biomass for food, feed, and renewable energy, and it will also act as a safeguard to promote sustainable agriculture and improve the integration of renewables into agriculture. Yes, even though that I try to talk about the fisheries issues here, but indeed, the agricultural issues would loom large behind this. Right now, in Taiwan, the Ministry of Agriculture already opposed to the deployment of those PV panels in the agricultural land. So the fishery, in the fishery sectors, it becomes an exemplified case. If we are not able to convince the public that is beneficial and also could reach the harmonization with the fishery integrity and the food security, it almost becomes not possible that we could further promote any kind of the PV development on the agricultural related land. And I'm going to explain that further. Okay, so we need to reach a balance between food security and the energy development policy. That's for sure, we all understand that. And we understand in the short term, we need to avoid inappropriate intervention in land use that could negatively impact agricultural production. We understand that. Otherwise, we are not able to pursue the long-term benefit out of this policy paradigm. And next, as an example for discussion, I try to introduce what we have done, what have happened, and what we do, and what we expect for this public communication solution that we could promote the fishery sector's aqua-voltaic development. And let's turn back to the energy situation of Taiwan. Taiwan is an island country, and we have only limited resources of energy. So you can see that I try to make a comparison between 2018 and 2022. So you can tell from the blue, green, and the light green, those are all fossil fuel, accounted for more than 90% of Taiwan's primary energy supply. And even after we try very hard to promote the renewable energy, which you can see on the top right corner, in the 2022, still over 90% of the fossil fuel dependency. And what's even worse, we need to import 90%, 98%, or 97% out of those fossil fuel primary energies overseas. So you can see how difficult an independent electricity grid without self-dependent energy resources and trying to reach the 2050 net zero goal. Yeah, it's difficult, but we are working on that, even though it's tough. We are working on that. And you can tell from here, by 2025, we have a national policy set up to install 20 gigawatt of solar PV. And also, we would like to reach like 20% of the renewable energy accounted for the power generation by the year 2025. So it's an ambitious goal. And among those efforts, you can see on the bottom, for the solar PV, 3 gigawatt will be out of the rooftop installation, and the 17 gigawatts will be out of the ground-mounted systems. And that's been the original policy goal set up by Taiwan. And after that, we try very hard. We need to find more land for those solar PV deployment. So we face the challenge like we have only limited land area available. And also we turn the situation into land fragmentation. So that caused the problem. And on the other hand, when we would like to seek for those solar PV goal, and you will see that if we will have like 17 gigawatt ground-mounted PV, among that, most of those will be expected to be generated out of the aquavoltaics development. So here, that's the problem about the land. Taiwan will require 25,000 hectares for ground-mounted solar. And among that, 19.9 thousand hectares will be allocated for aquavoltaics. So you can see, with a situation like that, we need to count on this, the fishery industry and the fishery sectors. So that will be just conflict with those fishermen's benefit and also the land conservations as well, directly. And then, on the other hand, you probably know that Taiwan has been one of the very aggressive fishery country in the world. And also, that's been like ranked by the 8th as the fishery products exporter in Asia and 22nd in the world. And also, it's accounted for like 0.18% of our GDP, and also 28% will be the total agricultural industry accounted for our GDP. So both the fishery and the agricultures, and those two sectors will be all included in Taiwan's agricultural department, okay? And we still have significant impact on our GDP if we try to develop those solar panel on the top of the fishery pond or the agricultural land. So that's the situation we face. And what would be the true issue about that under this policy? So on the left-hand side, those are the direct impact on our fishery industry. Reduced production, rising fish prices, and the monoculture of crops. Well, that's something to do with biological issues. And when we try to pursue the net zero purpose, that will lead to the well-planned energy policy prioritize stakeholders' interests. So that's the basic principle. When we care so much about the net zero, keep saying the net zero, then that policy will be pressed on the top. And that folks often push impact fishermen to public protest for their rights, and also will also invite several like agents or lobbyists to also participate in the scene. And that would even more interfere with the rational decision or deployment of the solar PV technology. And because of that, just in the early this year, we sort of turn down a little bit our goal from 20% to 15.5%. And among this, the ground-mounted solar target has been down from 70 gigawatt to 12 gigawatt. So you can tell that's all because of the aquavoltaics decrease. And because of that, we need to find a solution for this. And we try to integrate the stakeholders' perspective in our policy planning. And we believe that we need to consider various potential impacts at different stage and to include all related stakeholders in the policy decision and avoid post-implementation debates that would jeopardize the public trust. That's what we would like to do. And so when we are working on that, we need to figure out what would be the main barrier. Well, that would be the so-called weak problem. That means the issue has been complex and poorly structured nature with interconnected causes and impacts, and usually lacking clear solution. Well, we believe that's what we face in this case. And so that's a very popular methodology to apply here. We call that the analytic hierarchy process. And why it's meaningful? Because we can set up the objective to overcome traditional stakeholder communication challenges by using the multiple criteria decision-making analysis. And also, it's just idea for the complex decision scenario like this. And certainly, there will be some key features that we can pursue. First of all, it provides us with a structured technology. And so we can break down complex problems into manageable parts. And also, that could be good for the decision making. And also, it provides us a hierarchy structures for the development to include different levels of the goal, criteria, and alternatives. Certainly, you come up with the possible evaluation. So we would benefit out of that. We can accommodate conflicting and multi-dimensional objectives, and also handle immeasurable and incomparable impacts effectively. And in short, that would be 5 components for the application of this AHP that we can integrate and balance interests, and we can boost the credibility, and we can ensure consideration of security, and we can improve policy scientific basis. Certainly, will facilitate communication. And that's been a proposed structure that we are using right now in Taiwan. So you can see that we try to break down the factors to be considered into the social, economic, environmental, development, and recently we would like to add one more that would be the ecological and the biological. And so that's the way we try to promote our communication. And when we are doing that, we really figure out how can we handle that. For instance, we can categorize and analyzing different stakeholders group. For instance, for the PV sectors, they care more about economic investment benefit. And for the agricultural sectors, they care more about the product marketing. So you can tell from this. And also, we can predict whatever been prioritized, and so leave some room for the decision maker, not always just follow the national renewable energy policy as the priority. And because of that, we are able to identify the key factors that need attention. And we can measure and assess weights from different dimensions and perspectives. And we can understand the concern and the priority of different stakeholders regarding the risk factors. And for instance, here you can tell that for the fishery industries, they care more about aquatic product marketing and the food security, but in the overall observation, that has been only ranked by the 5th. So if a decision maker just follow the traditional policy-making process, they will probably ignore or drive down the fishermen's concern. in turns that will promote a lot of the post-implementation debate. So I think we can try to avoid that. And also here, after we conduct the whole survey, we figure out that the AHP application will be welcome because those two things, stakeholder communication and institutional framework, has been welcome, ranked by the second and the third. And finally, this application has been also applied in our geothermal development, backed up by the blockchain, and also supported by the AI implication, so that we are able to accumulate sensitive information and ready for the future or the further environmental impact assessment. So whenever there will be the new technology to be developed or deployed, I believe that this kind of the framework backed up by the advanced technology could be very useful and effectively conducted. So as a conclusion, we try to integrate humanistic issues into our aquavoltaic policy and leverage technology to harmonize these elements. This approach promotes sustainability and serves as a model for future renewable energy policy. And by balancing diverse perspectives and considering all factors comprehensively, we not only enhance policy effectiveness, but also ensure governmental transparency and public engagement, and also propelling us toward a sustainable and resilient future. Well, that's my presentation. Thank you for your attention.
Thank you. It may be of broader interest, this AHP approach to address multi-dimensional conflicting objectives. That's what we are really dealing with. And I appreciate the case study on aquavoltaics. So thank you for your presentation. Let me now call on Dr. David Laborde, the FAO Director of Agri-Food Economics Division, and a highly acclaimed global modeler. David, you have the floor.
Thank you very much, Mr. Chair. Ladies and gentlemen, thanks for this huge opportunity for me to talk about this question of food security in the context of climate resilience. And I'm going to emphasize the role of what I call agri-food economics, that is the name of my division at FAO, but really this how economic science in the context of agri-food system can be used to bring the world in the right direction, because unfortunately, even if some progress have been achieved, in particular on some climate target, actually in terms of food security, the last decade was not great, to say the least. And we know what to do, and I think on the climate side, for the last 50 years, actually science is very clear. If you go back to the testimony of Professor Sagan in front of the US Congress, all the elements are there, including the challenge of the future, but we didn't act, or at least the society didn't act properly. So the question is really about what are the incentives in order to move in the right direction, because we cannot force people to do things, even in the most strong regimes. So we have to understand it. And why economic science is pretty relevant is when you start your 101 course in economic science, people will say, okay, it's about using scarce resources. We want to have an optimal use of scarce resources. There is no free lunch in this world, and we have to deal with trade-off and synergies, as we already have seen a perfect example in the previous speakers. But also, it's about shaping incentives. That's really key in modern economic science. And we also have to deal with two issues that are efficiency and equity. How big is the cake and how we are going to split it? And the reality is that we cannot consider these two questions separated. And that's some of the big challenges we face today across nations, across generations. And in this context, we have to deal with it. And in addition to the natural science, where yes, we need quantities to balance, we need to make sure that we have enough water, we have enough land. We are not in a world where we have a central planner that is omnipotent, omniscient, and benevolent, and that is going to do this allocation. What we have is prices that guide us, and we can have these policies shaping these prices. But markets are imperfect, and policies are imperfect. So we need really to do good design in order to go where we want to go, and that requires data, science, and model, because all brains are limited, at least my brain is limited. So at one point, I need computers and equations to replace my limitation. And through that, we can deal with synergies and trade-offs. So that's why economic matters. I'm an economist, as you can guess now. But why agri-food? And we just don't want to talk about food, because of course, food is critical. No food, no life. No food, no GDP. Sometimes people say, what is the share of agriculture in total GDP? In terms of direct contribution, it's less than 10% globally. In terms of actual contribution, it's 100% until we are all replaced by machine. But we use water and land not just for food. We use it to produce a number of agricultural and forestry goods. At the same time, agri-food system represent 1/3 of the man-made emission. And here, we just don't want to blame agri-food system per se, because in this 1/3, 1/4 come from our energy sectors. It's not something that is disconnected, it's something that is integrated. We don't want to double count. But at the same time, all pathways that will lead to decarbonization in the energy sector give a role to agriculture and land use. We want to produce renewable energy, bioenergy, but actually decarbonizing our economies, phasing out fossil fuel, don't mean we phase out for carbon. We stop using carbon for fossil fuel, and we will need carbon from biomass to build houses, vegetables, to replace plastics, and so on. And that's the fourth industrial revolution that the bioeconomy, and I'm not going to talk more about it because we have people much more qualified than me in the room to talk about. Our agri-food system also at the core of the society, and this is this overlap between the economic system, the political system, the environmental ecosystem. Food has a cultural value. Of course, also a religious value, but just an economic value. Farmers need to make profit. They stop making profit, they stop to produce, we all disappear. Similarly, when we say that they have to produce in a cleaner way, they have now to deliver more than just feeding us, but feeding us in a sustainable way. They need to be paid for. We cannot shift the cost on them, because also most farmers in the world are not the richest people in the world. In all society, actually farmers work a lot for a very relatively low income. So we should also not start to put an unmanageable pressure on them. And our agri-food system also interact with energy system, and the question of bioenergy is one of it. The question of which energy we use to cook is another one, but also the health systems. Bad food mean bad nutrition, mean bad health. Now, there are similarities between these systems, but also significant differences. Agri-food systems are much more complicated. The level of heterogeneity about what type of technology we can use to produce wheat, just wheat, already exceeds the number of technology we have to produce energy. The scale of production also varies. You have very large-scale producers and very small ones. And even if it's of public interest, producing food is mainly a private sector activities. You go in any small village, you will see a market where smallholders try to sell their food up to the global traders. Health systems are still dominated by the public sector. So how we shape these systems based on their complexity, their richness, and the fact that it's still a private-driven activity, it's important. But at the same time, this agri-food system is one of the most unique situations to deliver, for example, both on mitigation and adaptation on the same time. If you look other part of the economy, it's in many cases mitigation project, we decarbonize, but you know the adaptation space for a nuclear plant is not huge. When we farm, if you increase the carbon content in soil, you do mitigation, you do adaptation. Same thing when you start to use seaweed to feed your cattle. You contribute to mitigation, you contribute to adaptation. So we have a lot of options. Now, why food security and actually food insecurity is an issue, there is a moral imperative. We have a right to food that is recognized. The human rights approach was already reminded by my other colleagues, very well surrounded. It's also an efficiency issue. I mean, if you don't care about ethics, if you don't care about morale, if you just care about economic growth, without good food, you don't have a healthy population today, but also tomorrow, because we need to grow human capital, and we know how much malnutrition has a cost for future generations. And the future is about more complex situation, more technology. Even farming tomorrow is much more complicated than farming yesterday. And so human capital is key in terms of economic growth. And if we don't have economic growth, we cannot have a big cake to share, and we don't have the resources to adapt. You know, I think that's, you know, when you are poor, that you are not really resilient because you don't have this capacity. We already discussed this today. So, you know, growth is important. Malnutrition has a huge cost, like 3.5 trillion a year just for child malnutrition. Our agri-food system also have a lot hidden costs. It's more than 10 trillion a year, between 10 and 20 trillions. We have uncertainty because it's complicated, but it's big. So again, it's more than 10% of our global GDP that is lost in hidden costs. Malnutrition, including overnutrition, put also pressure on our health system, and we know that they produce carbon and they are costly. And last but not least, today also people realize that when we have malnutrition, when we have overweight, obesity, you can have a security problem. In the US, the most recent assessment showed that 1/3 of the young population is too heavy to serve in the military. So fixing agri-food system contribute to many objectives, from the more ethical and moral one to the more practical one. And at the same time, lack of food security means lack of political stability. So just to tell you that first, hunger has been on the rise for the last 15 years. So, you know, when we say, oh, we need to prepare to climate change, we have already people that are hungry, 735 million today. So it's 120 million more than before COVID. And conflict, climate shocks, and economic slowdown are pushing numbers high, but the main cause is still inequalities. And on the right-hand side of my graphs, you will see, in particular, the green light is, the blue line is how much calorie per capita we produce. So at the world level for food use, not even thinking about the leakage, just for food. Every year we produce more food per capita, but still hunger is on the rise. So that's why, you know, beyond the global situation and beyond the fact that our agri-food system as a block deliver more food on the plate every year, we still not share it in an optimal way. And the question of inequalities is critical. Here you see a snapshot of the level of food insecurity of the world. So basically you have more 2 billion people that are food insecure, 735 million people chronically hunger, 2 billion people food insecure. That's 68% of the population in Africa, but also 8% in high-income countries, and the situation has deteriorated over the year, but still a contrasted situation. Now, just to give you also how in 20 years the world may change on some aspect, and here I show you the evolution of LDC's countries and the European Union. LDC's countries is basically 1/3 of the people that are hungry today, so it's 245 million people. 20 years ago, they represented 10% of the population. Today, they represent 14% of the global population, so that their share in the population. The European Union, at the same time, has shrunk, and they moved from 7%, broadly speaking, to 5.6%. Now, if you look at the share in agricultural production, the same LDC that represents 40% of the population just produce 4% of the global food production. The European Union has seen a share that has decreased over time, so we have to think how different players play a different role at different years over time. And now you see that the European Union produces more food in terms of share than its population. But the last part is what I want to raise, because when we talk about emission, and emission in agri-food sector is very different than other emissions. The LDCs represent today 15.4% of global emission in agri-food system. The European Union, 7.17%. So if you compare this to the share of production, you see that Europe is pretty efficient. The carbon footprint of European agri-food system is not the problem. The problem is a lack of efficiency in low-income countries. And it's not because we don't have the good soil or the good water, it's because we don't have the money to invest. They don't have the access to the technology, and they are lagging behind, and it has a cost for them, high level of hunger. It has a cost for the world because they emit too much compared to what they should if they have access. So addressing this unfairness is at the same time good for everyone, especially if you think that we have one planet, we have one total carbon stock. The goal is not to get the best student becoming a bit better, is to make sure that the people that we have left behind join the efficiency. So as you see, as I've said, the situation is complicated. We have some challenges, but actually climate change is going to make things worse. So it's impacting the way we produce food in terms of water, land, quality and quantity, but also workers. Sometimes we forget about the farmers. A drought-resistant seed is a great news. But in many places in 15 years already, it will be too hot and too humid for farmers to work most of the day. So you can give them nice drought-resistant seed. In Europe or in the US, they will have an air-conditioned tractor, so they will manage. In many places in Africa, they will not. So we have to think about this impact of climate change on all the aspects of the production side, including in terms of how it accelerates the depreciation of your knowledge and of our capital. It has also impact on the demand side. We see that when basically you have more carbon in the atmosphere, your crops grow at a faster rate, you have more biomass, but less nutrient density. So our capacity to absorb nutrients will also be impacted. We also see psychological impact. And here there is growing research on this nexus between psychological distress, climate anxiety, but also food habits. And that's not just, in high-income countries. You go to the seeds, you go to the Pacific Island, and you see this reality today. High level of obesity, high level of climate distress, and a vicious circle that has started. And of course, higher climate change means more food loss and waste. The more the world is hot and humid, the more it becomes complicated to protect and conserve food. So a lot of the problem we have today will accelerate, including in terms of inequalities across generations, across countries, within countries, between rural and urban areas. But even in the same rural areas, we see that already climate shock impact more women than men, poor than rich. So not doing a thing means more inequality. The full set of policies and where we spend money today is not aligned with what we need. And we are not spending enough actually in our agri-food system. Even if you hear that, the world is spending billions, actually 500 billion on farm subsidies, the total share of agricultural spending at the world level coming from public budget, in total public budget, is 4%. So it's not even the share in GDP or the share in expenditure. So we publicly and privately invest in these sectors. Only 4% of the climate finance go to agriculture and land use. And I will say, last but not least, the international aid that we provide for food security and nutrition is not enough. And when we have seen increase in the recent years, it go only to emergency activity. So we are trying to solve the problem when it's already there, and it becomes worse and worse. So we spend more and more in terms of trying to stop the fire in the house and not in terms of trying to avoid to get a fire at some place. So it's not sustainable. We have a number of things that can get worse. Here you will see a lot of elements on the slide that explain why when we don't design solution properly or where we just think, we just have to do that. But the question is not what we have to do, is how. And there's a lot of things that make the story more complicated in terms of non-linearity, in terms of political economy, in terms of leakage effect across borders. Something that economists would like to talk about is the Jevon paradox. We have problem of discount rate, and we need to factor all of this in a good way. And when we mess up things, we have bad solutions that are implemented at scale, like we have seen in the biofuel, money spent on crop insurance that try to reinforce the wrong specialization, or carbon credits and carbon market that have not been designed initially properly to land use and smallholders and end up in wasting resources. We need to be resilient. What I'm just going to conclude on, sorry, but a lot of things we like to communicate. The future still means that even if we say in SDG 2 we are going to eradicate hunger, based on the last projection we do with model, we still have 600 million people in 2030 that will be in chronic hunger, and much more in food insecurity. So in December, we tried to bring together these different messages at FAO. where we try to bring basically science for action. That's really what we want to do with achieving SDG 2 without bridging the 1.5 target. So still saying, you know, we want to deliver on food security and nutrition. That's what people care on a daily basis. But without climate action, we will not be able to do it and to continue to do it. So it's not one or the other. Both have to be integrated, but I will say people first. And that's this question of just transition and improve efficiency and global rebalancing that will have to be tackled front and center. Without dealing with inequalities within and across countries, we miss the target. You will see more information, but at the end, and through integrating both biophysical and economic modeling, we show that there is still a pathway to reduce the carbon footprint and actually making our agri-food system carbon sink by 2050 and providing good food for all today and tomorrow, meaning that making sure that hunger disappears, making sure that everyone can afford healthy diet, but also that everyone wants healthy diet. Because it's only when we will see this, then the world will change. Thank you.
Thank you very much. Fascinating touch on efficiency, equity, justice, all closely linked to the malfunctionings of the food system. We have a few minutes for open discussion on the food issues, and I would like to suggest to the audience that besides the two presentations which we have listened to in this session, I remind you of Sunita Narayan's, Kenneth Chepek, and Jean-Jacques Mohinda's presentations in the previous session on water, which actually connected also to land use and agri-food issues. While you are preparing your questions, David, you flipped over one graph modeling the future of prevalence of undernourishment. What was your assumption about the evolution of climate crisis underpinning that modeling?
So in the chart I have shown, we have just projection up to 2030. So we have under some climate assumption behind them, but basically no more additional extreme events. So that's the type of things, you know, even in the recent years, we have moved from a number of La Nina to El Nino to La Nina. We just have this projection under a kind of business as usual situation. But what I want to say is that at the end, in a lot of this model, what matters is how much agricultural productivity will evolve in the next 5 years in a net terms, you know. So how much we adapt. So are we adapting faster than the climate shock or not? Or just do we adopt technology? Because if you look in low-income countries or in Africa, today you are struck by two things. First, the last 10 years, 0 productivity gains in terms of total factor productivity. All the effort have been absorbed by other shocks like climate, conflict, or things like this. And most of the increase in production has been extensive. And that's also why we have this carbon footprint. We have not seen this productivity gain. And the other is, if they continue with this trend, they are in trouble, but we are all in trouble. And so that's where we also need to see an acceleration of productivity gain in a sustainable manner in the global south. But for example, this acceleration will not take place if climate change occurs at a faster speed and is not factored in this projection. And that's why we are still at 100 million people.
Sounds a bit optimistic to me. Sunita, okay, I gather 3 and then pause and then get back to you.
So fascinating, David, really fascinating. I have some sort of disquiet about some of the issues that are happening in our world and struggling now to understand what this sustainable agriculture means. And the reason is that I'm rather sort of worried about the use word productivity and they use the comparison of different agricultural systems as they exist. I mean, if you look at the European and the sort of the industrial agricultural systems, both in Europe and in North America, and you look at the subsidy levels that are given to farmers. I mean, if you look at Europe's subsidy levels, and even now farmers are on the roads in Europe arguing that they cannot afford the cost of the green transition, in spite of what I would call an obscene subsidy from our point of view. Our farmers do not get subsidized. They have no choice but to discount the price, the cost of the land, the water that they take their food from. And it's in this context that we, in our world, are sort of asking, what then is that sustainable food system which doesn't focus on the cost of inputs being high, which then leads to higher productivity, which puts farmers into a debt trap, which puts them into an inability to work the land sustainably. Because even in this part of the world, you're not working the land sustainably. And I think that's really where the questions of reinventing agriculture for a climate risk world, but more importantly for nutrition, for nature, for livelihood, that becomes an issue. And I think we really need to deconstruct some of the words we use. I mean, for me, the word productivity, I cannot understand. To me, income in the hands of farmers, I can understand.
Very much for those presentations. And I do want to pick up on your question about the assumptions in some of this modeling with what we've heard about some of the potential tipping points in climate systems that we may be approaching. Is anyone in the agri-food world looking at how, what kind of economic tools can help us and what kind of adaptation strategies, for example, Europe can use in a world where in one case it is a warming, and in another the Atlantic overturning circulation slows down or stops, and you actually have a cooling of up to 3 degrees per decade. How does one plan and how does one economically model such potential divergent futures, which actually could both occur?
I saw Jean-Jacques, and was there one other hand? I take one more. Okay, Romina, and then we go back to you. David, you take notes.
Yeah, thank you very much, David. My question is pretty much related to what you've asked. I think you're reading my mind, Sunita. So one of your graphs, David, you were showing how ineffective are the production systems in the least developed countries, producing less and emitting more. If you have ministers in this room, a minister of agriculture, what would be your advice in terms of policy implication? So will it mean probably, shifting probably agricultural subsidies from inputs to farm power to energy, like Sunita was talking about? I just want to hear your perspective from an FAO point of view. I mean, last week in Nairobi, we had, a big conference of the African Union discussing about fertilizer subsidies. We're still talking about subsidizing input. So and here you are demonstrating that it's actually a bigger issue than that. So I just want to get your perspective on that.
Let's take a break. And so David, subsidies, productivity measurement, subsidies again, and modeling tipping points, your challenge.
Thanks a lot. Thanks a lot for all these questions, fascinating elements. So subsidies. Here I think that actually we're in a situation where we are 4 giants in terms of subsidies that are the US, EU, China, and India. And India input subsidies now have accessed actually the one from the European Union. We are going beyond the $60 billion in India every year. Of course, India is a large country, And the problem, I will say, is not so much about these subsidies, it's about how they are used, especially in terms of fertilizer and in terms of energy, and are not supporting productivity gains defined properly, meaning trying to produce as much as we can with as little inputs as possible. And we need to include land, we need to include water, we need to include carbon and biodiversity as inputs. And today we don't measure this properly. So we really have a problem of measuring productivity. But for us, it's simple, you know, it's how much you get for what you put in terms of capital, labor, land. Today, that's what we monitor. But we don't monitor the other aspects. And that's what we do at FAO, that's what we do at OECD. And that's something we want to push people to really be accountable for this holistic measure of productivity. Now, as I've said, farmers all around the world suffer in many cases. You all have heard about the unfortunate suicide of Indian farmers. But in Europe, the suicide rate of European farmers is 5 times higher than the suicide rate of Indian farmers. We are all this community that suffer. And of course, we live in different opulent worlds. But I just want to say that we should not oppose farmers from one side to another. In many cases, the society is putting pressure on them. Some farmers are doing very good, but also we should differentiate landlord than farmer, because that's a lot of social implication. So I just think we need better subsidies, more targeted. And also the problem we have today is we have now more and more of the G20 countries, put them like this, that have the fiscal means of putting subsidies and sometimes entering in subsidy wars. When we have most of the low-income countries, in particular in Africa, that doesn't have money to spend. That's the sad reality, you know. And in Africa, most countries are more taxing their agriculture than subsidizing their agriculture. And when they do it, yes, they use a fertilizer subsidy. Not a great thing. But here it's where also the political economy matters. When you give fertilizer subsidy, you create clientelism. Every year, you have farmers that depend on you. It's very different than empowering them, giving them the right technology, giving them the right human capital, giving them knowledge about their soil, that they can decide the right practices. So here you have and to answer your question about what advice you say to policymakers, I mean, if you are a policy advisor, you say, yes, we need to support your smallholders. They face a lot of problems in terms of access to finance, access to knowledge. They are also in a world where actually they are competing with people that have more support or more access to technology, so there is a case to support them. If you are a political advisor, you say, yes, but you want to win the next election. So all this empowering, public good, nice things is one story. Make sure they vote for you, make sure they vote for you is giving them a fertilizer bag every year. And moreover, you can also have additional corruption benefit from this. So that's the issue. But on the graph, what I want to say is, I say to, and we try to say to government in low-income countries, yes, there is a need of adaptation. But adaptation money is basically 20% of the climate world finance. You have a huge potential in mitigation. And the point is not to say, oh, you should not grow your agriculture. Yes, you need to grow agriculture for the livelihood of your people, for the food security of your people. We are going to add 1 billion people in Africa. These people need to eat. But right now, the agri-food system is inefficient. There is huge mitigation potential in all low-income countries. Let's attract money there. And we have to change the narrative between who has to act and who has to pay for this. And so the more we channel resources to the right place, then you can get this win-win. And then you have an issue of agriculture in low-income countries. I can start to discuss about mitigation, but I want money for that. If you ask just me to cut my emission and I don't have access to technology or upgrade, then it's, okay, you want me to die of hunger when you continue to emit in the north. So really, we need to see this, but we need to see this win-win solution. On the tipping point, that's, for me, a major thing that worries me. I mean, what I spend my time trying to say to policymakers is, don't start to fabulate on what a 2, 3, 4 degree, because sometimes they come and say, can you make simulation about a 4-degree world? I mean, I don't think we have science for that. What I say is 1.5 will always be a lot of adaptation. And 1.5 in average means very different things in different countries, in particular in some tropical countries. And that's a lot of efforts to do. So don't try to think we will manage that 4 degree. No, we don't know. As you said, human agriculture has never operated in the world we are going. So let's limit the damage. We may overshoot or not, We may, but we want the same policy we want to put in place will be the same. We want to minimize the thing. But that's also sometimes where we have this illusion about, in one of my slides, I was saying science is important, but between science and technology, there's a gap. Science may save us when technology may not. Because, for example, what will be European, West, even Italian agriculture in 30 years from now? We don't know. It can be a world where we have much more drought, or the Gulf Stream is impacted. We are at the same here, at the same level that basically Boston. And the weather of Boston and the weather of Rome is different. So why we should invest in drought-resistant seeds in Europe if we end up with the climate of the northeast of America? So that's why we don't want to go there. And we can put this in the model and tell you how the different things, but it will not be really useful. The point, and that's why we have this roadmap, the goal is not to go there, not to play with the devil, because starting to go in this is playing with the devil, and we should not do it. And I think I cover some of them, but I will be happy to follow up bilaterally.
The program says open discussion, then synthesis and next steps by yours truly, and then another open discussion. I skipped that in between synthesis and next step. I have on my list you, Romina. Benjamin, had I seen a hand up from you and Kenneth? And then I asked for very brief interventions from someone like Ramanathan. And then we open it up to the broader issues which we heard so far, and I will close this session on time. Romina.
Thank you. So you mentioned, if I understood correctly, that adaptation has its limits, and where there is a lot of science already that between 1.5 and 2, where we might be activating 11 tipping points, as it was said here. So you say that your attention is mainly on trying to mitigate and not surpass 1.5. So my questions are two. One is, what is your plan for methane emissions in the sector, as methane is essential, as we have said earlier, to slow the rate of warming in the near term? And second, if you're using the principle of common but different in responsibilities and capabilities to differentiate between big agribusiness contribution and small farmers, and what is your work on that? I mean, shouldn't big agribusiness be paying, for example, a tax, and then can you help the small farmers? I mean, what is your work on that? Thank you.
Benjamin?
So I'm Ben Holton. I'm Dean at Cornell University College of Agricultural Life Sciences. So David, I have a couple of questions for you. First, I think some of the data you were looking at with respect to emissions from developing economies or global south. So I was curious if those emissions are considering net import and export of emissions, because you get a very different picture of the global food system when you start looking at where the emissions are being, exported from and who's importing those emissions. And I think that tells us that the complexity of the global food system does require more of a holistic perspective. So I'd just be very curious if you've thought that through relative to where the emissions are coming from, the sort of interventions that could be helpful. The other thing is, I think, how do we kind of decenter the commodity argument that we have right now in our food system to one that starts to appreciate ecosystem services, biodiversity, water, carbon? Because I think if we keep centering the market forces on the commodity itself, we are going to continue to find ourselves in a position where we need big subsidies, profits are driven through green revolution technologies. Some of those technologies have been useful, but as we've seen, they're not always bringing about benefits for soil health, long-term survival of our food system. So I'd just be very curious your thoughts.
Dennis?
Thank you. I just wanted to add
and beat another drum. As we're looking at the agricultural sector, one of the most important thing is if we have to look at the total infrastructure input to agriculture and the risk, we didn't talk very much about the risk to transport system. And the transport systems is such an important link of getting inputs to the farmers and things back to the market. And those are some of the most vulnerable under flooding. And the type of damage is going to take a long time to repair, both short-term and then long-term. And then, as you pointed out, David, the labor heat stress that we're going to see in the ag sector is enormous. And they're starting work on that. And just how do you bring that in, and how will that productivity work? Are we going to till at night with flashlights on our head, or what we're going to do? But the thing about agriculture is it's at the nexus of all the stresses that we're seeing in the infrastructure. And so we have to look at it holistically. And there's such a small adaptation resilience pot that we're fighting for it. And we have to be careful in countries that we do it systemically and harmoniously and complementary. Because if we just do willy-nilly and things, we're wasting our resources. So we have to have meetings like that where we're bringing the brain trust together to put the priorities. So we don't get that always in our models, but we do with price wedges and the transport and things. But really important that we look at these other stresses at the same time.
Some of these questions were important comments to all of us. So, David, feel targeted, but not too much, if you want to react to some of the comments, especially to the one from Romina.
Yes, no, so I, once again, thanks for all these points. No, I think this question between big players and small players is an important one, but a complicated one. So first, even large-scale food companies are not companies that make huge profit compared to the rest of the economy. You know, even the Cargill and the Bunge are not the Shell or the BP companies. If you see on the long run their level of profit or the level of salary of their executive people, because that's how, you know, profit is already when we have paid wage. But if you look at the oil sectors, you will see a premium in all the executive positions that is insane. So food companies make money, like any companies, but they are not hyper profitable. So I just think that, you know, how much taxation we can do on them overall, and at the end, they will also potentially bring the cost to consumers. And every time we choose the price of food, we hurt more poor people than rich people, because poor people across nation or within nations spend more on food than rich people. So we really have to be careful about how we internalize all the prices when we talk about food. So yes, I think that different should have not the same level of, for example, regulatory pressure, monitoring, but the goal is not to let the small players out of the game. That's always what worries me, you know. If you look about food loss and waste, or food losses today, large farms all around the world are much more efficient than small players. Smallholders have a higher share of food losses, and that has a carbon cost, than big players. So we need to bring them technology to them, and that's where we need to support. So maybe some can come from a taxation within the sector, but I will be very careful with that. I think it's more the global collectivity that will say how much we want to pay for having food, good food, in a sustainable way. That's a society choice more than, you know, doing some redistribution. Of course, there is some abuse. Of course, there are some companies that need to be looked at carefully. But that's the point. Second point, yes, on methane, we need, not what we assume, we need a reduction. Now, the methane story is more complex, in particular in the food sector, is we need to cut it because it can deliver short gain, but methane is something also on which we can have a steady state in the future. So, and because we are going to see also an increase in livestock demand coming from the global south in the next 20 years, we need to do this global rebalancing. We need to reduce livestock emission in the global north in order to create space in the global south, because the world is going to eat more meat and more animal product. The question is by how much? Plus 7% if we think that everyone will adopt the type of Eat Lancet diet, plus 100% if everyone starts to become high-income type of diet countries. But in all cases, it go up. So in all cases, we need to make the livestock sectors more efficient. And once again, in particular in low-income countries. Per liter of milk, a Swiss cow emits 70 times less than an Ethiopian cow because better genetics, because a Swiss cow is basically spending most of her energy and life producing, when an Ethiopian cow spends most of her life surviving. So really how we feed, how we design the system is important, because especially in low-income countries, there is a lot of micronutrient deficiencies, and in the next 15 years, the best way to bring micronutrients to a lot of the local community is through the livestock sectors. If we're in Rome today or in Los Angeles, you go to your supermarket, you can get your B12 from fortified cereals. You go in South Kivu, it's not the case. So really, different parts of the world are going to be able to deal with this nutrition aspect. Last point I want to make is on this question of emission, because I think it's important. Here is from really the supply side. But at the end, when we talk about the efficiency of a system from a productive point of view, that's the accounting we need to do. But that's the difference with the actual footprint of population. And that's the difference, once again, between the responsibility and who has to pay for what and who has to act. Last point I want to say is, because I think it's pretty important for all the scientists, is yes, through the IPCC, we have a lot of good science, but a lot of these stressors have been considered independently in a lot of the IPCC reports. And when we start to add them up, that's where it's not going to be, oh, potentially climate change is going to increase food insecurity by 50 or 100 millions. It's by much more. But today we have not done this assessment because we have to combine them in order to say where, in many cases, no more farming will exist, where people will not stay in farming because it's not profitable, and we don't have this science yet, and that's something we all need to work together on.
Colleagues, I'm going to proceed as follows. Ram and Virgilio have raised their hands. I will then close the Q&A session, make a few closing remarks. We'll ask you to stand up and stretch and gather energy for the next session, because that's on energy. And then we carry on from there. Ram, you have the floor. It is an issue. So the question was food waste and losses. The about 30% sum out of waste and losses, waste being at the retail and consumer level, losses being in the production system, especially in low and middle income countries. Yes, it is a big issue, Ram, if I may venture an answer. The sum of it adds up to the total emissions of your wonderful state in the west of the United States, of all emissions. So it's a big emission. What to do about that? It's technological and infrastructure investments in low and middle income countries, which need to be enhanced. And it is behavioral change and taxation in rich nations. However, there are recent surveys. I've seen one on food waste in Nairobi, Kenya, coming to the same level of 100 kilo per person per year, which we have in Germany. So the dichotomy which I hinted at is maybe disappearing. Urban food waste in emerging economy countries needs to be addressed. Virgilio, you have your last chance before we stretch.
Well, just to broaden a little bit the analysis of the food production systems, I think in addition to the carbon emissions equation, there is water use and chemical use. In case of water use, it's about 70% of all water use in the world is by agricultural systems. And as we talk about the concept of using wisely water, I think that's an issue that needs to be addressed, how to improve the existing use of water in the agricultural system. And another point is chemical use. There's a lot of chemicals that have been banned in the developed world that are being exported to countries which have less governance on these products. And that is a source of health issues to many agriculturalists. So I'd just like to raise these 2 points just to broaden a little bit the scope of the analysis. Thank you.
Thank you, Virgilio. Let me sum up a few points about which we have not discussed. I think we can be quite optimistic about new plant breeding and resilience-related technologies in agriculture innovations because of progress in bioscience, biotechnology, and where I'm a bit pessimistic in that respect is that these technologies and this science-based knowledge is not transferred fast enough around the world to low and middle income countries. And that maintains a northern bias. So that's where development partners, private sector, and so on can play a strong role. Where we probably should have also discussed a bit more is about the supermarketization of the food system and the fast trend towards automation of the whole food industry, including in Africa. We have recently done a survey. I'm sure, David, you are familiar with these trends also. Those are giving us opportunities, but also have large negative employment effects and transforming the so-called smallholder subsistence sector and threaten cottage industries and so on. And lastly, we may in the future talk more about what to do about nutrition-sensitive social protection systems. School meal programs around the world, the millions of school children whose food consumption is not sufficient being addressed through solid and nutritious, solidly designed and nutritious food programs, and safeguarding consumers. The consumer side of the food system, I think, needs to be addressed more under threat of volatile markets and volatile labor and capital markets. So these 3 points I felt we can watch more in the future. Actually, Ram, you recall 2 years ago when we had the preparatory meeting for this, we touched on these, but we may need to address them further in future gatherings. Thank you for a vibrant discussion on the food issues, more to be done. And in a moment, I will, after you have done your exercise standing up, hand over to Chaiken Bao and Governor Healy. Thank you.
It's like a heavy burden we are carrying.
Ladies and gentlemen, please take your seat. If you want to have dinner, proper time and a sleep, please get back to your seat. Co-chair, can we start? Governor, as she's getting up. So let's start the session now. Thank you so much. I hope the coffee break or the energy break was helpful. We are very honored to lead you to the last session. It's hard to get the last session on energy and get people energized. So this morning, my colleague from China mentioned that water was everywhere, and I do believe that energy also is everywhere. It's in air pollution, it's in water, it's in development, it's in social equity. Not only that, we need energy to do this session. So I'm honored to lead this session with Governor Maura Healey, who gave me the honor to run the first part, and she will be running the second part. Without further ado, and for the sake of time, permission, Governor, we would invite the first speaker who will talk about clean, affordable energy transition, Danesti, from my right side, from Connecticut. The floor is yours for your presentation.
Mr. Chair, and thank you all who are here. Thanks to the organizers, but a special thanks to all of you who hung with us through the day. I don't have to tell anyone in this room that we're gathered at a challenging moment. In fact, if there were a common theme to the presentations of the day, that might be it. It is, of course, the case that the climate change challenge has been fully chronicled already, but I want to simply add to the mix of concerns the work on planetary boundaries done by Johan Rockström, done by Professor Catherine Richardson at the University of Copenhagen and others, which highlights that in addition to the climate challenge, 6 of the 9 critical Earth systems, 7 or 8 of which are beyond the climate system, are also being breached or at risk of being breached. So we really do need to think about this as not just a climate resilience challenge, but as a sustainable future challenge. And in that regard, I want to turn us from the science foundations to that challenge to the policy responses, centered as this session is meant to on what's required for an energy transition that delivers us to a future that we need. And in that regard, I want to set the discussion in what I call the broader context of 21st century thinking and what I sometimes refer to as the sustainability imperative. Now, before I try to unpack what that means, I want to take you back to one of the most important lessons I learned as a young official at the U.S. Environmental Protection Agency in the run-up to the Rio Earth Summit of 1992. And for those who attend the regular gatherings, the annual climate change summit meetings, those COP meetings as we've come to call them, this would count as COP 0, from which we count up to 28. And the Secretary General of that gathering, that original 1992 UN Conference on Environment and Development, was a great Canadian diplomat businessman named Morris Strong. And I remember sitting with him as we waited to go in and talk to the EPA administrator in March of 1992, a month before the last of the climate change negotiations, just a couple of months before the gathering in Rio. And I asked Mr. Strong what he was thinking. how did he think things were going as we headed for Rio. And he said to me something I've never forgotten. He said, Dan, when you bring 115, turned out to be 120 presidents and prime ministers together with all their cabinet members, thousands of media representatives, and what turned out to be the largest NGO gathering in history up to that moment, tens of thousands of NGOs, he said there's only two outcomes: success and real success. And I put success in air quotes because we've had far too much success in the 30 years intervening. And so the question I want to ask today is, what does it take to deliver real success? And I think we can start by saying that there's some clarity beginning to improve our vision. And I want to go to what came out of COP28 in Dubai in December. Again, a number of you were there. There was a lot of discussion of the commitment to transition away from fossil fuels. I honestly don't think that was such big news. That has been said in other ways and other times over many years. There was a lot of celebration around the loss and damage agreement, which I actually think was important as a signal of a commitment of fairness to those that may be the victims of climate change. And I celebrate the political thoughtfulness of shifting toward a forward-looking structure of support and away from a backward-looking structure of liability that would never have been agreed upon. So that is political creativity and good policymaking on display. But the real challenge, the real demonstration, I think, of the meaningful outcome from that COP was the outcome of the global stocktake. The exploration of what, when you add up all the national efforts at climate change, the so-called nationally determined contributions to climate change action, what do you get? And the answer was emissions still going up, not going down. And even where they're coming down, and there's a number of countries where they're coming down, as we already heard, including my own, but in very few countries are they coming down fast enough to get us to a net zero emissions future by 2050. And indeed, the team at Yale that I lead that does the biennial environmental performance index is suggesting that only one country, and I won't make you guess, is on track, at least at this point, to a net zero position in 2050, and it is Denmark. And even they are not clearly going to be able to hold on to their trajectory at the current moment. So then the question is, what do we do differently to meet the moment? How do we structure policy to deliver transformative change? And I really do want to put a question to all of you. What's your theory of change? And we've heard some today, and I do think all of them have a part to play. But I think the fundamental piece of this is the energy transition. And so I want to bear down on that with you. What is it going to take to get us to the vision of the 2015 Paris Agreement and the more specific target of the 2021 Glasgow Climate Pact? Again, net zero greenhouse gas emissions by mid-century. And I think the fundamental challenge is getting us to not just a clean and renewable energy future, but in the spirit of this gathering, one that is affordable and accessible to all. And that is not a simple thing. We really do need to build out this clean energy infrastructure across all nations, all communities, at speed and scale. So I want to highlight 5 elements, 5 policy elements that I think are fundamental to this. First is, and this has not been attended to as much today as I would have thought, innovation. We fundamentally need innovation, and not just technology innovation, but new ways to engage the public, new mechanisms of finance, new policy structures. So a broad structure of innovation is fundamental. I think we also need, and we've heard it already a bit, and perhaps we'll get into this more in the coming couple of days, finance. We need to ensure that all nations and all communities can move together to this clean, renewable, and affordable clean energy future. And that does mean scaled up commitments of capital, especially going to the global south. It's going to require blended finance, as we call it, mix of public resources and private capital through creative tools like green banks, green bonds, and other similar structures. And Governor Healy gave us one example that she's working on in Massachusetts. And I do think we need to remember that clean, renewable, and affordable energy is what economists might call a mixed good. So it has elements that are a public good because it's trying to do something different and we need to pay for the increment that is clean and affordable. But it is also a private good. It can be sold. Electricity has a price. So we need to think about how to structure these blended finance systems to do what we need to get done. And I do think it means we need a fundamentally new role for the World Bank and the other multilateral development banks, for the IMF, in parallel with private capital. So I'm a big believer that the Global Financial Alliance for Net Zero, launched by Mark Carney in Glasgow, has got a role to play. Now something like 400 private financial institutions committing, although some are backing away, but committing to do their lending in alignment with a net zero future. But beyond this, I think we need as well broader business engagement. I actually think that corporate sustainability is the fundamental step towards a truly sustainable future. And so I don't want to put anyone in this room in an awkward place, including particularly the elected officials. But it turns out that the really important decisions are made by the folks that have their hands on the steering wheel of the corporate world. These are the folks that decide what gets built, how it gets built. Government can shape the road that they drive on, but these are the folks that we really have to figure out how to transform their behavior. And in that regard, I do think we should particularly focus, as we have heard already today, on the countries, 20% that represent 80% or 90% of emissions, but also, perhaps even more importantly, on those biggest companies. We have a global GDP of just over 100 trillion US dollars, and more than half of that comes from the top 1,000 companies and their choices and their activities all around the globe. So I want to start today by saying the real key to transformation in my mind is a new ethical foundation for business. And I think we have to go beyond the teaching of management schools, and I teach in part in a management school of 50 years, which emphasized something called the Friedman Doctrine. And that was the suggestion that we should have as corporate leaders a mission of maximizing profitability. Sometimes this is called the shareholder primacy doctrine. We should maximize profitability up to the limits of the law. But I have to tell you as a lawyer that the law is a net, not a wall. And there's too much ease with which companies can reach through that net and pull in profits and have private gain at public expense. And that's what I think we have to bring an end to. So I think we need a new core principle of stakeholder responsibility, where companies accept that they have a duty of care, of course, to their owners, but to their suppliers, their customers, their workers, their communities, their states or provinces, and society more broadly. So again, the fundamental principle, no private gain at public expense. This, by the way, echoes what some of you in this room will know very well as the polluter pays principle that's been discussed in environmental policy for decades and is reflected in dozens of international agreements, or what economists would call the need to end uninternalized negative externalities. And by the way, this doesn't mean the end of pollution. It means you choose whether to stop your pollution or pay for the harm you're causing. So it's really about making people accountable for the harm they cause. And in this august setting, I want to offer what I think is the foundation of this principle. So it's not really a new principle. It's the golden rule. Do unto others as you would have them do unto you. It's fundamental to all the world's major religions, and it's certainly the animating spirit of Pope Francis's Laudato Si papal encyclical. And this leads to the question I think we really need to dig into: how do we move business toward a sustainable future? How do we make sure that companies can't profit by spilling harm onto others in any form? Pollution up a smokestack, effluent out a pipe into a river, emissions into the atmosphere. All of that should be seen as unacceptable in the 21st century going forward. So then you might ask, Dan, what's your theory of change? You're challenging everybody else. My theory of change is we need to find a structure of rules that hold business accountable. And I think, having spent 30 years thinking about this, the answer is the international trade system. Now, you might say that reflects the fact I've been on public service leave from Yale for the last 2 years, working in Geneva at the World Trade Organization. And that's true. And I have had the inspiration of enormously hard-charging, energetic leader of the WTO, Dr. Ngozi Okonjo-Iweala. And I do think she is the right person to lead what could be a transformative change to deliver on this promise. And I think what we want, and we heard a little bit earlier with David's discussion about agriculture, is we want a World Trade Organization remade to really deliver on this. Trade, we all know, can help move at speed and scale the technologies, projects, services that we need for a sustainable energy future to all corners of the globe at ever lower costs. But what we really need is a trade system that can provide the discipline to ensure corporate accountability, corporate sustainability. And for those who are interested, I worked in parallel with my time at the WTO with a network of academics on something we call the Villar Framework for a Sustainable Trade System, laying out what a really, truly remade trade system might look like. One with new economic underpinning, beyond the market fundamentalism, the neoliberalism of recent days. And again, if anyone has really pushed that agenda, Pope Francis gets credit for the need for a new economic foundation for not just global commerce, but local commerce. And we do need sustainability standards for business activity. We do need consistency with the WTO's original mission, launched at the time it was created in 1995 in an agreement called the Marrakesh Agreement, which says, and I'm paraphrasing, the purpose of the trade system is not open markets, trade liberalization, it's sustainable development. And I do think we need to push towards that with new rules on subsidies, as David told us, a restructured commitment to developing countries. And let me close then with what I think is really the fundamental issue here, is how do we do this transition in a way that is fair? And I do think a just transition needs to be thought about carefully, and I want to give you very quickly 6 dimensions of what I think that fairness requires. First is participation, inclusion particularly of historically marginalized communities. So we need broad participation. We need to protect the poor. Low-income families cannot bear a disproportionate burden of the transition. We need help for and transition assistance to the old economy workers. And this is not just a matter of fairness, it's a matter of political necessity. We're not going to get past, as Arunabha and several others told us, the challenge of those who are going to be burdened by these changes, especially farmers, but also fossil fuel communities. We also need to help frontline communities, those who will bear the cost of change as they try to invest in new ways of doing things, but in particular those burdened by inaction. And if we heard anything today, and that is that there is a huge threat if we don't take up the issue. And the burden of inaction falls very heavily on the developing world. So my last 2 dimensions are international equity. How do we share the burden? We heard about common but differentiated responsibility, but please remember the name of the Pope's encyclical, On Care of Our Common Home. And that really does emphasize commonality over our differences. The last element is intergenerational fairness, which we did hear some about already. And I do think it means we need to be very careful as we push forward to think about country-to-country fairness, and also not just climate change attention, but also biodiversity, the other great existential threat. We need a nature-positive agenda. We need regenerative agriculture and sustainable food systems. So all of that argues that we've got a lot to do across many vectors, global, national, subnational, provincial, and local. We need a special focus on corporate behavior and a new structure of incentives to change how businesses operate. We do need revitalized global governance across the Bretton Woods institutions, the World Bank, the IMF, the WTO. And I think together, we really can bear down on what's required for real success. Thank you very much.
Wonderful. Thank you, Dan. I think your package of ideas would be a great foundation for my other neighbor. We have great neighbors in this side. Arunabha Ghosh, to talk about how the business model in energy would take into account everything that Dan has mentioned. Then the argument can start already. So the floor is yours.
Thank you. Just wait for the presentation to come up. Super. Well, if you had any doubts whether you'd be energetic enough, just in the lead up to dinner, I think Dan has put paid to those doubts. Thanks, Dan, for setting us off on a brilliant start. If Dan asked us provocatively what is our respective theories of change, but outlined his principles, maybe in my presentation, I will try to see or explain how some of those principles you outlined, Dan, can be operationalized. So the what and the how kind of playing. In India, we call it the jugalbandi, the do it. So here goes. In my presentation, I have titled it Accelerating Energy Transitions, and it's very important that we recognize there's not one, but many different energy transitions that are underway, particularly in the developing world. And we've got to be not just cognizant about them, but imaginative in the innovations we deploy towards them. As a way of introduction, I mentioned earlier, I represent CEEW. Our work is not just on energy. Many of the issues we've been discussing through the day, whether it's air or water or food or mobility or cooling, finance, technology, it's all part of our portfolio of work in India and outside India. But today, I will focus my comments on the energy transitions. So let me explain why I say that the energy transitions as plural. Normally, we've thought about the shift towards sustainable energy as a binary, that you have dirty energy and you move to clean energy. When we look at developing countries, the first energy transition is from no modern energy to modern energy. That's energy transition number one. Let me illustrate this with an example. In 2015, when the Sustainable Development Goals were announced, we came out with the results from a survey that at that time it was the world's largest survey we had undertaken on energy access. And India had the dubious distinction of having the largest number of people without access to electricity. In 2017, a program was launched to connect households, not just villages, to at least a wire. Whether an electron flows through it or not was a subsequent question. So in 18 months, 28 million households were electrified. Effectively, that means that 11,000 human beings in India got access to a wired connection every hour. Now, the world has still 700 million people without access to electricity. We would need to electrify 11,500 human beings every hour all the way to 2030 to meet just one aspect of SDG 7. So what India did in an 18-month period with intense effort, the world has to do this for the remainder of this decade every single hour. The first energy transition is from no energy to energy. The second is that the patterns of energy demand will shift quite a bit, especially in developing countries as rural populations shift to urban areas. And therefore, what is primarily agricultural demand of energy then moves towards heating and cooling for buildings such as these, transportation systems, and so forth. The third energy transition then is about the shift from dirty energy towards cleaner energy, or dirtier growth towards more sustainable growth. And the fourth energy transition that is almost never talked about is actually the deeper integration of developing countries and their energy demand into how global energy markets operate. So what I'm going to illustrate to you a little bit is the shift towards sustainable energy requires sustained efforts towards all of these different transitions. This illustration shows you that for developing countries, that opportunity for a leapfrog towards sustainable energy actually can take many different pathways. But it is those economies where we've got to concentrate our attention, because 88% of additional electricity demand until 2040 will come from emerging markets. So how do we do this? I want to first illustrate some of the how on utility scale renewables at scale. This graphic shows you how India's electricity system has shifted rapidly towards a cleaner electricity system, but not nearly as clean as it needs to be. So 2010, the National Solar Mission began. We had less than 20 megawatts of solar at that time. Now India has the world's 5th largest solar market by deployed capacity, world's 4th largest wind market by deployed capacity, and overall the 4th largest renewable energy system in the world. Another way to look at it is over the last 10 years, power capacity has grown in India by 82%. Coal-based capacity has grown by 50%. Renewables capacity has grown by 388. So what needs to happen for economies where the energy demand curve is upward sloping rather than flat is that you've got to win the renewables game at the margin, rather than a substitution effect for every single new electron should ideally or probabilistically greater than half should be coming from renewables. How do you do that? So one of the things, I mean, the agro-photovoltaic presentation was really interesting because many of these economies will struggle with land. But one of the innovations that India attempted was something called solar power. Now, of course, it will not work in all parts of India, and it will certainly not work in all parts of the developing world. But land pooling helped to provide an easier plug-and-play model for utility-scale renewable energy development, who would otherwise have struggled and taken a lot more time to find the land plots and then build out the infrastructure. So if a decade ago it took about 18 months to build, say, a 500 megawatt solar power plant, now it'll take less than 7 months. Precisely because that's the kind of public-private approach that was needed to ensure that the land pooling combined with the evacuation infrastructure was ready. Therefore, the evacuation infrastructure becomes equally important. We were just discussing during lunchtime, India has a more integrated grid than the United States. I was living in New York when the Northeastern grid collapsed 20 years ago. Right now, at least technically, we can wheel clean energy from down south in Tamil Nadu upwards north, wind power from the south, solar power from the west, hydropower from Bhutan, and so forth. In fact, I was in Sri Lanka just last week. We're trying to establish an interconnection from wind power in Sri Lanka to southern India. So about 10,000 circuit kilometers of transmission lines deployed, 9,700 kilometers of interstate transmission lines deployed. That was another innovation. And the third innovation was the institution. So the risks of investing in renewable energy in developing countries is a challenge. How do you mitigate some of the risks? In India, an institution was created, the Solar Energy Corporation of India, which served as an intermediary in signing the power purchase agreement with the project developer and a separate power sales agreement with the utility, which then inured the project developer from the financial situation of the utility. But utility scale renewables is not the only story. So can we scale small scale systems? So I'll just give 3 examples. One is in agriculture. India has already the largest number of solar-based irrigation systems deployed in the world. But the way it is trying to do that is many different routes. Route number 1 is about 10,000 odd systems that are completely decentralized. Another 2 million solar pumps, and then about 1.5 million that would be grid-connected solar irrigation. Those maps that you see is a tool that we developed at CEW, mapping every single district in India on 20 different parameters, from food cropping type, crop water level, the water level, the crop patterns, access to finance for farmers, etc., to determine where you would get the best return on investment for which business model of solar irrigation deployment. But it need not be only about the on-farm application. Off-farm, but in rural areas, we estimated that using clean energy for livelihood activity is a $50 billion market. What might be those technologies? Those pictures show you, it's from a program we launched called Powering Livelihoods, solar-based food dryers to reduce what Professor Ramanathan was talking about, food waste. In fact, not only does it reduce food waste, it increases the farmer's take-home income about 2x or 3x, because you're not doing distress sales in hot tropical areas. solar-based power looms, solar-based, my favorite example is solar-based hydroponics for cattle fodder. That itself is a $2 billion market where the commons have been taken over. So how do you grow cattle fodder on far lower water and land footprint basis? Oops. Right. So, and a third is distributed energy in urban areas. Again, at lunchtime, we were discussing how utilities have an instinctive pushback against distributed energy. So we started working with utilities to see how do you design business models where utilities would make money, consumers would save money, and the losses would come down. And we designed business models for what we call the roofless, those who live in tower blocks. And then what we call the creditless, those who might have homes but are very poor to have a credit history. Based on some of the experiments we've been running across the country, now there is a nationwide program that has just been announced for 10 million homes to get rooftop systems, which alone would account for at least 30,000 megawatts of solar power. So you can take distributed energy and take it to scale. But then there is another dimension. So far of those different energy transitions, I've talked about no energy to energy, talked about cleaner energy, dirty energy to cleaner energy. I've talked about rural to urban dimensions of energy, but there is another dimension. It is that deeper integration into global energy market. Now think back half a century. We had the first oil shock, and it created an energy security architecture for the energy demanders of the past and for the energy fuels of the past. We now need an energy security architecture for the energy demanders of the future, i.e. the developing countries and emerging markets, and for the energy fuels of the future, solar, wind, batteries, minerals, etc. Let me just explain why. Some numbers we crunched when we were the strategic partner for India's G20 shows that if you look across the world, for solar PV, the number of countries that had concentrated imports, means they were reliant on very few countries for bulk of their solar PV imports, went up from 38 in 2012 to over 71 in 2021. For lithium-ion batteries, went up from 19 to 49. So even as countries are doubling down and now tripling down on their renewable energy targets, they are reliant on fewer kind of countries and sources from where to source these products. This is particularly problematic for low-income and low-middle-income and upper-middle-income countries. High-income countries, their dependence on those concentrated imports is about 60%. But for low and upper-middle-income countries, that is nearly 100% in many of these cases. So when we need to go into the hundreds of gigawatts of clean energy infrastructure that needs to be deployed, energy security considerations will begin to kick in. These are no longer just pilot demonstrations. This is about maintaining resilience in a different way. The same applies on innovation. Dan talked about innovation. Now, the G20 accounts for 85% of the patents for clean tech filed over the last 20 years. Within the G20, 5 countries account for 85% of the patents granted. So there is a huge concentration of clean tech IP. And this does not mean IP should be given away for free. We have to think about how do you create a new paradigm of technology co-development, which is not just pooling of financial resources, but technical resources, human resources, and most importantly, our geographies as the laboratories where new clean tech oriented towards the hot topics can be developed. And the same challenges arise for energy security from critical minerals. 15 countries account for 55% of the identified critical minerals for the clean tech transition. But within them, 70 countries, just a few countries account for more than 70% of the actual mined minerals. So unless, in fact, my home abuts the DR Congo embassy, so yes, I usually knock on their door. So yes, we need to now think of ways to not just dig up virgin mines. We have to think about circularity and beneficiation of critical minerals at source. And the final thing, I know I'm over time, I'll just take a minute more. Final thing is we've had a session on air, but we need to link climate action with clean air. So in this room, apart from me, there are 3 more commissioners of a new global commission called Our Common Air. Soumya is one of the co-chairs, Maria Nera is sitting across, and behind me is Gina. Helen Clark is the other co-chair. And our proposition, which came out last month, was that you got to focus on not air pollution alone as a liability, but clean air as an economic asset. And then develop the financing strategy that combines climate action, public health, and air quality interventions as a new way to drive action. But in addition, I just came to the Vatican here from Paris, where yesterday there was the first clean cooking summit that the IEA conducted. And if we think about the clean cooking benefits for ambient air quality, in India alone, the push for LPG cylinders that we were talking about earlier has resulted in a 30% reduction in the annual PM 2.5 from domestic cooking. Or black carbon per household, at least the households that are using LPG as a primary fuel, 30% reduction in black carbon. So the huge potential for the air quality benefits from a completely different developmental push that has gender implications, equity implications, and so forth. So what am I saying? That there is more than one energy transition, and therefore we have to design for scale, but with business models that can be both large and small. That emerging markets and developing economies now need to become nodes and not just recipients in the interdependent and more diversified value in the clean energy story. In the process, they have to participate as co-developers of the new energy technologies with shared intellectual property. We've got to focus on the beneficiation and circularity of critical minerals, and we have to invest in clean air as a driver of both a public health good, but also private benefits for households and economies. Then we have some of the operational characteristics of the WATT principles that Dan provoked us with. Thank you.
Wonderful. Thank you so much, my friend. I thought after Dan's presentations that we have sparkled so many great ideas. But after this business model, my mind is being blown down. Seriously, it's becoming a very complex issue, the issues of energy. But we are not at the end of our pain of understanding the framing of all these things, because the issues of policy is coming really seriously into vote. So, Mr. Minister, I'm pretty sure, Wenchen, you will bring that perspective, the policy perspective on the energy issues. So the floor is yours for an overview.
Thank you very much. Thank you very much, my co-chairs. As we approach dinner time, I think my greatest contribution to today's session is to speed up my presentations and end it within 15 minutes. I'll do my best. Thank you very much. First of all, I would like to give my greatest appreciation to the honorable organizers of the event. It is a tremendous honor for me to be part of this meaningful summit. Today, I will be using Taiwan as an example to show our how we plan our pathway to net zero emissions with a focus on the energy sector. In 2021, the IEA presented a report, Net Zero by 2050, a roadmap for the global energy sector, which sets out the pathway to the global energy sector to reach net zero emissions by 2050. Net zero by 2050 hinges on an unprecedented clean technology push to 2030. The path to net zero emissions is a narrow but achievable one. Staying on it requires immediate and massive deployment of all available clean and efficient technology. The global pathway to net zero emissions by 2050, detailed in this report, requires all governments to significantly strengthen and successfully implement energy and climate policies. By 2040, the focus is to attain a zero emission power system, aiming for 70% of the energy supply from renewable sources by 2050. Industries will heavily depend on new infrastructure development, integrating CCUS, hydrogen energy, and electrolysis technology into emerging sector by 2030 onwards. Efforts in the building sector involve prohibiting the sale of a fuel boiler, advocating for heat pumping, and implementing new construction and renovations of existing buildings to adhere to net zero standards. Looking ahead to 2050, transportation will predominantly feature electric or fuel cell vehicles, while electrifying aviation and maritime transportation poses significant challenges. Following the landmark conclusion of the UAE consensus in COP28, a more ambitious blueprint for our future generation was outlined. They try to decarbonize the future generation, which sets a clear political signal that aims to embrace and reframe the ambition of all nations' 2035 NDCs. The NDC 3.0 represents a transformative shift, serving as economic transformation and national investment plan for One Earth future. In Taiwan, we also set our course toward achieving net zero emissions. President Tsai declared on April the 22nd, 2021, to set a 2050 net zero transition target, which sets the wheel in motion. On August 23rd, 2021, the Executive Yuan launched the amendment of the Greenhouse Gas Act and incorporated the goal of 2050 net zero emissions in the new Climate Change Response Act. By March 30th, 2022, Taiwan began planning its pathway to achieve net zero emissions. The Executive Yuan officially released the 12 key strategies to achieve our 2050 net zero transition goal at the end of 2022, and adopted the 12 key strategic action plans for net zero transitions on April last year. At present, how to plan a feasible 2050 net zero pathway is our main challenge. Our government aims to formulate a clear and comprehensive carbon reduction path and a green growth strategy. Transition strategies include energy transition, industrial transition, lifestyle transition, and social transition. These four transitions requires two crucial foundations, that is technology R&D and a comprehensive climate legislation. Taiwan's 12 key strategies to achieve 2050 net zero include the promotion of wind solar power, hydrogen energy, innovative energy such as geothermal and biomass, power system and energy storage, energy conservation, CCUS, electrification and decarbonization of transportation, resource circulation, carbon sink, green lifestyle, green finance, and a just transition. As we can see, almost half of these 12 key strategies relate to energy. Taiwan's annual greenhouse gas emissions are around less than 300 million tons of CO2 equivalent. That contributes to almost 0.5% of the global emission. According to our updated 2030 NDC, Taiwan aims to reduce greenhouse gas emissions by 23 to 25% compared to 2005 level, bring it closer to the reduction trends of neighboring achieving advanced Asian countries. Under our climate governance, Taiwan has made significant strides in managing the growth rate of greenhouse gas emission. This progress has been evident as emissions have gradually decoupled from economic growth rate. This chart shows Taiwan's energy mix. As we can see from the chart, 83% of our power comes from fossil fuel, and more than 90% of our fossil fuels are imported. This represents a huge challenge for an energy transition through transformation to transition from high carbon to low carbon and carbon-free sources while ensuring a stable power supply as well as energy security. According to the outcome of the COP28, achieving triple the installed capacity of renewable energy and doubling energy efficiency have become key focus for countries worldwide under the Global Decarbonization Accelerator. I'm glad to share that Taiwan has seen rapid development of renewable energy in recent years, particularly in solar, with the installed capacity in 2023 reaching 3.8 times of that in 2005. Our offshore wind power development in particular is probably the largest in Asia. As of April this year, nearly 300 offshore wind turbines were installed in the Taiwan Strait, accumulating a total capacity of 2.25 gigawatts. Enhancing energy efficiency is another crucial task. The IEA also stated that improving energy efficiency is currently the first fuel. Since the early 80s, Taiwan has introduced the Energy Management Act, which has led our industries to gradually improve their energy-consuming equipment. Therefore, Taiwan won the 8th position in the International Energy Efficient Ranking in the world. As part of our comprehensive approach to climate action, we have further regulated energy efficiency improvement in the new Climate Change Response Act. It covers not only building and household appliance equipment, but also encourages nationwide behavioral change. As the previous slide mentioned, if NDC 3.0 means encouraging transformation plans, then the turning point are innovative technologies development and diffusion. We could define a green competitiveness as resulting from our low emission industries, which use advanced technology applications and are supported by green finance. Under better management from all emission scope, all value chains and industrial system will jointly move toward a low carbon manufacturing and contribute to global mitigation. For instance, we all know that TSMC dominates semiconductor production in the world. Outstandingly, under their efforts and the support from our government, each kilowatt of electricity production for the TSMC chip will help the global value chain to save 6.8 kilowatt of electricity to the world due to the energy efficiency of the chip they manufactured. That's how Taiwanese industry contribute to Scope 3 emissions to the world. Meanwhile, we also devote our R&D resources and capacity to seek opportunity for deploying geothermal, bioenergy, and marine energy. As previously mentioned, climate legislation is one of the two foundations to support our transition. Let me just briefly introduce our key legislation, the Climate Change Response Act. This act sets out division of labor between different agencies as well as different levels of government. The act also focuses both on mitigation and adaptation. For mitigation, the Climate Change Act offered two carbon pricing instruments. One is carbon tax, we call it carbon fee, and another is emission trading system. A carbon fee will be deployed in the short term, while the cap and trade system might be introduced in the long term. Currently, we're preparing the implementing regulations for the implementation of our carbon fee. Initially, the carbon fee will impose on the manufacturing and power sector that emit more than 2,500 tons of CO2 equivalent, covering both direct and indirect emissions. This threshold will be gradually reduced. Meanwhile, to comprehensively consider all aspects of impact and stakeholders, the rate of carbon fees will be determined by a carbon fee rate review committee that is composed by different stakeholders. And the revenue from the carbon fee will be injected to the Greenhouse Gas Management Fund. and will be fully earmarked to specific uses as designated in the Act, mainly mitigation, adaptation, and just transition. The Climate Change Response Act also set up a voluntary baseline credit system where carbon credit projects can be applied and reviewed before obtaining carbon credits. The authorized carbon credits can be used to offset carbon fees liability. Our government has amended or related regulations on this voluntary offset program in line with ICVCM's core carbon principles to ensure the environmental integrity and the quality of this carbon unit. In terms of adaptation, the National Climate Change Adaptation Plan was adopted by the Executive Yuan last year. And there are three main aspects in the national adaptation strategies. First, the government will develop industry risk assessment guidelines and collect necessary adaptation information. Second, we will assist our industries in identifying climate risk, including state-owned and private sectors. Thirdly, we will also propose adaptation strategy guidelines and relevant adaptation measures database for public use. With these instruments, our government will communicate more and coordinate more with various groups, enabling Taiwan to move smoothly toward our goal of achieving net zero by 2050. Thank you very much.
Thank you so much, Wen-Shen. I think you put a finger on the feasibility conditions for the theory of change, the business model, and everything we have heard so far. And now actually to deep dive into the reality of things, we will go from Taiwan to California. So when I read the title, California Adapting to Climate Change, my brother, it sounds like kind of fish swim. So you have a lot of resources, you are a very wealthy state, and now you need to adapt to climate change. We want to know how California is adapting to climate change. The floor is yours, and you have the point.
Well, thank you so much. It has been an impactful day. As a non-scientist, I've been both educated and alarmed by what we've learned today. The acceleration of the likely overshoot, the appalling inequity that continues to exist where those most vulnerable to climate change have the least resources to protect against their vulnerability, the inevitable complexity of this transition. But actually, my few minutes are going to be spent being optimistic. I'm optimistic because we have leaders like Governor Healy that exist across our country and the world in cities and states and regions. Massachusetts, California are 2 of 24 American states that are taking aggressive action on climate change thanks to their governors, representing over half of our population and half of our GDP. If you look globally, we have hundreds of subnational governments that are exerting similar leadership, many of which are in the room. California is a member of what we call the Under 2 Coalition that includes 270 governments representing over 50% of the global GDP that are focused urgently on working together to implement our climate action targets. And this year we are focused on fossil fuels, methane, and equitable climate finance. I should mention in the United States, we benefit from, as has been said, the most aggressive climate action president we've ever had. So we've also heard that the solutions exist. I was inspired by our presentation on the sustainable agricultural practices in Rwanda, the decentralized water management in India, the sponge city everywhere approach, the urban greening across our world. I mean, these solutions exist. So it's not a question of if, it's a question of how and how fast. So I want to share a theory of the case from California. And I'll recognize that we are a well-resourced state, and everybody is going to have their own pathway. But I think ours is an encouraging story. We're a large, diverse democracy. We are 40 million people. 1 out of every 4 Californians starts their life outside of our country. That's fuel for our innovation, fuel for our strength. If we're measured in GDP, we're the 5th largest economy in the world. But make no mistake, we've been battered by climate change. 7% of our state has burned up in the last 5 years. We had 2 millennial droughts in the same decade, punctuated by the wettest 3 weeks in our 175-year history, creating catastrophic flooding. We had a regional heat wave that almost knocked out our energy grid. And the second most well-used rail service in the United States from Los Angeles to San Diego is not operating right now because of sea level rise driven coastal erosion. I lead an agency of 25,000 people focused on all of those topics. And I thought my tenure over the last 5 years would be a lot more proactive than it's been able to be because we've had to be responsive. But even so, I'm very optimistic. We are investing in each of these challenges and under the umbrella of an adaptation strategy that's prioritizing our most vulnerable and relying on science to drive our investments. Because this is an energy panel, I want to focus on another point of optimism, which is the major progress we've made. Now, California has ambitious targets. No news there. I think the glass half full as an international community is net zero is no longer a debate across the world. It's how we're going to do it and how quickly. But I think what we can share is the tremendous progress that we've made. In 2007, we were proud to establish one of the first legally binding requirements to reduce carbon emissions in the world. And the target was to reduce emissions to 1990 levels by 2020. And we met that 3 years earlier, or earlier than 2020, or 3 years early. One key piece of that was a cap and trade system, which put a specific binding lowering cap on sources of stationary pollution and then charged polluters as that cap went down. We've raised $28 billion over the last 10 years as a result of that program, 67% of which has gone to environmentally burdened communities. That's been critical. We're now focused on net zero by 2045. And good news to report there. In California, 1 out of every 4 vehicles sold in California right now is a zero emission vehicle. We set a target of 1.5 million vehicles in the last governor's administration. That was frankly laughed at. And we achieved that target 3 years earlier, or 3 years early. Last year, 60% of the energy that we consumed across the year, again, in an economy as large as California's, was derived from clean energy sources. And remarkable fact I'm really excited about, in the last 30 days, over the last 30 consecutive days, every electron that's powered California in this time has come from clean energy. That's solar, wind, and water. It's actually 59 out of the last 67 days. So for those that suggest that 100% clean energy is not possible, we prove them wrong. A key piece of that has been scaling up significantly battery storage so that we can retire our fossil fuel plants. We've been able to achieve a 1,000% increase in the amount of battery storage we've generated. And our governor, who you'll hear from tomorrow, just announced 10,000 megawatts of battery storage. So I'll also share that, as the governor talked about this morning, this leadership doesn't come at the expense of economic development and prosperity. It's the basis of that economic growth and prosperity. And we're really proud that California's GDP growth has outpaced our national GDP growth in that time. We clearly have our challenges. We have a grid with about 50 gigawatts of energy generation on it. We have to triple that to 150 in the next 20 years while balancing for affordability, which is an issue in California, as well as continued reliability as climate change accelerates. We also have to do that in ways that ensure that this transition doesn't leave folks behind. As affluent as California is in the world, we have tremendous inequity in our state. And if we make this transition and make the same mistakes we've made in the past of leaving folks behind, then as our governor says, we will have failed. I'm really excited that we're investing in regional economic development planning, ground-up planning from 13 regions across California, and then focusing on what their economic development priorities are and how can our climate policies and energy investments actually advance their vision for growth and prosperity. While I have the floor, I want to acknowledge nature-based solutions. Yes, energy, yes, transportation, yes, buildings, but yes, nature. Ecosystems, home, our home, these are our life systems. And I think places like California have focused traditionally on technology, as I said, energy, transportation, buildings, not enough on nature. We are righting that wrong, and I'm really proud that last month we announced our first very specific land use management targets across 8 landscapes in California: forests, farms, deserts, cities, you name it, and all focused on reducing emissions from our land. So in our very specific roadmap to achieve carbon neutrality, our nature-based solutions, our land sector is now a variable, and we're focused on measuring the carbon flux in each of those landscapes and achieving that over time. And I'll submit to this group that it's important that we're all lifting up nature-based solutions, but then let's quantify specific targets for nature-based solutions and then mainstream them into our climate action. I've been so gratified in this job to learn from our tribal partners, Native American tribes in California, on traditional ecological practices. Remarkably, as we heard earlier, some of the smartest, most important things we can do have been done for millennia. And it's been modern government that has disconnected ourselves from those practices. And so I'm so proud that we have done everything from reintroducing beavers, nature's engineers, in places we didn't think they existed historically until tribes helped us understand that, reintroducing prescribed fire or cultural fire on the landscape to reduce the threat of catastrophic wildfire. And then just last week, I was really gratified that we transferred $100 million to California Native American tribes for ancestral land return, getting land back to dispossessed tribes for purposes of tribal sovereignty and environmental conservation. And this is working. I mentioned 7% of our state has burned in the last 7 years, or 5 years. Over the last 3 years, we've spent $2.7 billion on proactive upfront actions to improve the health of our landscape. And while we've got a big assist from Mother Nature over the last couple of years, those investments are working, and we've had moderate wildfire seasons, and we hope that continues. Likewise, on floodplains, flooding, we've learned from others. While we have some gray infrastructure solutions, we're emphasizing and putting more money into nature-based solutions, notching our levees, our walls on rivers to let rivers overtop and flood seasonal floodplains. That's critically important to reduce flood risk on downriver communities, but it's also creating important habitat and recharging groundwater basin. So we're learning from others around the world. I guess I'll lastly say that there is so much to be alarmed and discouraged about, but there's also so much to be optimistic about. And I think the people in this room that I think we're all so thankful that we're convened by His Holiness, the Pope here, have to be truth tellers, but we also need to be solution finders, and I'll say hope givers, right? As this news permeates to people that don't do this like we do, it can be paralyzing. And it's up to us to maintain focus and maintain optimism. I consider optimism not a choice, it's a discipline. It's a discipline we all have to exercise, because what's the alternative? One of my heroes is a climate scientist in the United States named Katharine Hayhoe, who spends a lot of her time trying to explain climate change to people who don't spend a lot of time understanding it. And she talks about we have to maintain hope by taking action. And it's that cyclical loop that's going to keep us moving forward. So I'll lastly say, we can do this. We have to do this. Failure is not an option. And so I'm really thankful to Marcelo, to Ram for convening us here today. I'm excited that you'll have 2 more American governors that will join Governor Healy tomorrow, who are excited to sign this planetary compact. And this needs to be one more step in the journey we need to make together. There's no time to waste. Thank you.
Absolutely. I think I'm sitting on the right side of the room. These ideas are really great, and I like the last portion. When you see something just as a problem, you will be limited in the possibility of solutions that you have on the board. So the nature-based solutions and everything that California did to respond to climate change, the energy sector, is really commendable. Now, I withdraw my words that a fish can swim. It's not that California is facing climate change as every part of the world, but you're doing the right thing for the right context. So at this point of the session, it's my honor to invite the governor to lead the discussion with 3 people who have been pre-identified to give the impression, and she will give the wrap-up of this session, and we adjourn the session. Governor, the floor is yours.
Thank you so much. We'll move right into this last portion where we'll have the benefit of hearing from a governor, a climate chief, and also a member of the Biden administration. And so we look forward to their comments today, and we'll begin with Christina Costa from the White House.
Really, and I want to begin by offering my thanks for being invited to join today's gathering, and just gratitude to the Holy Father for bringing this incredible group together here today. I would like to briefly share some reflections on this discussion, and also to provide a perspective from the federal level of the United States about what we are doing to address the climate crisis that we all face, in partnership with the subnational governments, with the civil society leaders here in the room, as well as with the private sector. And so I want to thank again Governor Healy for her leadership, and my friend Wade, who has been more proactive than he would have you believe from his presentation in driving climate leadership from California. We are coming together at a moment when, as we've heard all day, that the realities of the climate crisis have never been clearer, but as many have spoken to today as well, our ability to address those realities has also never been greater. We heard earlier today from the 2023 IPCC chair, but I want to actually quote the 2018 report on 1.5 degrees, which said that reaching net zero emissions by mid-century will take, quote, a transformation of the global economy on a size and scale that has never occurred before in human history. That is the task that faces all of us, and it is the task that we in the United States are taking extremely seriously under the leadership of President Biden and Vice President Harris. Rising to meet the climate challenge is ultimately a matter of equality, of care, and of cooperation to ensure a safe future for all of humanity. That is why President Biden and Vice President Harris, very early in their time in office, set a science-based target to cut U.S. emissions 50 to 52% in half by 2030, and to achieve net zero emissions by no later than 2050. And it is why, under President Biden's leadership, we passed the largest investment in clean energy and climate action in history. And my role is as Deputy Assistant to the President for implementing that law, the Inflation Reduction Act. The Inflation Reduction Act, just very briefly, invests in reducing emissions across the entire economy, in the power sector, transportation, industry, buildings, and in agriculture. And we're beginning to see the results of this historic legislation, as well as of the other actions that the Biden-Harris administration have taken. In 2023, last year, U.S. emissions fell by 1.9% economy-wide, according to the Rhodium Group. That is the largest single-year reduction outside of the peak of the pandemic in U.S. history. We know that we need to do more. We know we need to accelerate those reductions, but it is still an incredibly remarkable achievement to see that reduction at a time that the economy was actually growing. The IRA alone, the Inflation Reduction Act alone, will enable the U.S. to get 80% of the way to the president's 2030 goal, and our regulations and the actions of our states and our business sector will get us the rest of the way there. It is truly an amazing thing to be able to sit in a room like this and to say, credibly, we will achieve our 2030 emissions reduction target as the world's largest economy and as the world's largest historical emitter. It is critical that we operate from that place of global climate leadership. Also, though, as we are implementing this law domestically, we're trying to lead by example at home of what building a truly inclusive and equitable clean energy future can look like. That means that we are centering workers in the creation of high-quality jobs in our implementation, and we're investing really deliberately in communities that have been left behind, as Wade was speaking to in the California, as the U.S. economy has grown over the last decades. That includes legacy energy communities that have historically been dependent on the fossil fuel economy for their jobs and their livelihoods. It includes low-income and disadvantaged communities and families who as we heard in compelling statistics throughout the day, benefit the most from these clean energy solutions, not just globally, but in the United States as well. It includes tribal nations and indigenous communities who are centered in our work and who now have new tools and resources from the Inflation Reduction Act to own their own clean energy future and to power their own economies. And it includes environmental justice communities who for decades in the United States have just borne the brunt of the health and economic impacts of industrial pollution. I highlight these aspects of our work because while climate change is a crisis of global proportions, it is also an opportunity to reimagine how we build and finance and to operate our energy systems, to embed equity and justice in our public policies, and to build truly resilient communities and societies, as we've been talking about today. We are coupling that domestic investment with tireless diplomatic efforts to scale up global ambition and action. Last year at COP28, countries reached historic agreement to transition away from fossil fuels for the first time ever, which, with all respect to my colleague from Connecticut, was not a foregone conclusion. But even beyond that, countries also agreed on specific sectors in which to accelerate action before the end of this decade. So alongside our domestic investments, the United States is working to catalyze investments globally. At COP28, we announced a package of $3 billion to the Global Climate Fund, and we're working with partners to mobilize billions more for specific reductions in methane, in supply chains, in agriculture. And it's actually projected that US investments through the Inflation Reduction Act are going to reduce costs for critical clean energy technologies, especially emerging technologies like hydrogen, by as much as 25% in the coming years. And that means that for every ton of carbon pollution we are taking out of the US system, those cost reductions driven by the IRA are going to reduce global emissions by another 2.4 to 2.9 tons. So as we continue to make progress implementing the Inflation Reduction Act domestically, we are going to increasingly be able to knit those actions together with our international climate leadership to ensure that those global benefits are realized and are realized in accordance with the same principles that we are implementing the IRA domestically. That's one of the reasons, not the only reason, but my boss, John Podesta, who both oversees Inflation Reduction Act implementation and recently succeeded John Kerry as our senior climate diplomat, recently announced the creation of a White House task force on trade and climate, to Dan's presentation earlier, and made clear that our door is open for discussions with other governments, with Congress, with stakeholders on how to incorporate climate into our global trading system. So at the same time that we're doing all of these things to mitigate emissions, which is absolutely critical, we also need to, and we are investing in helping communities deal with climate impacts. This is not an either-or choice. We must build resilience, and we must build it now. We know that developing countries and the most vulnerable populations can't adequately prepare and respond to climate impacts without support. That is why President Biden has committed to work with Congress to provide $3 billion annually for adaptation. That is the largest such commitment in US history. We do need Congress. It is a regrettable fact, but we're working on it. And we've been implementing and scaling up the President's Emergency Plan for Adaptation and Resilience, PREPARE, since 2021. PREPARE sets a goal of helping more than 500 million of the most vulnerable people in developing countries adapt to and manage the impacts of climate change by 2030. A major aspect of this initiative is climate information and services, which can save lives and assets. Just 24 hours of warning before a heat wave, for instance, can cut the resulting damage by as much as 30%. But 1/3 of the population of the world does not have access to that kind of data and information. And I think one of the United States' most longstanding contributions to the global climate system actually is our investment, our federal investment in climate science and services, which most people don't appreciate, but I think this room really will. And so through PREPARE, we're continuing to help close this gap by expanding access to NOAA's heat wave forecasts and decision support services in African, Caribbean, and Pacific Island nations. But we know that there's more to do and more to do rapidly to make sure that the most vulnerable have what they need to withstand the growing climate crisis. In 2015, as we all know, the Holy Father issued a global call to protect our common home. We've seen so much progress, but we know we have more to do quickly, together, with hope and with purpose and with action to prevent further climate damage, to build resilience, and to protect the future of our common home. So thank you again, everyone, for welcoming me today. Thank you, Marcelo. Thank you, Ram. And back to you, Governor Healy.
Thank you so much, Christina. I'm comfortably speaking on behalf of Governor Newsom, Governor Hochul, Wade, our teams, to say thank you. What the Biden-Harris administration has done, $1 trillion in climate funding through the Inflation Reduction Act and a couple other pieces of legislation. It's huge, it's game-changing, and we hope we can continue to work forward with you. I was Attorney General under the prior administration's tenure, and we spent a lot of time in court trying to hold the line on any number of things. So we appreciate your contributions. Incidentally, Christina and I went to the very same little town high school. I find it remarkable. We come to Rome to meet one another. So thank you for that. And now we'll move to the person who is really the brains behind the operation and anything I articulate, and that is our climate chief for the Commonwealth of Massachusetts, Melissa Hoffer.
Thanks, Governor. Well, good afternoon. Thank you. My deep gratitude to Pope Francis, who's been a personal inspiration to me, the Pontifical Academies of Sciences and Social Sciences, Ram, the Chancellor, for convening us. It's really an honor to be here. So at the outset, it's really worth noting that we're in the midst of not one, but three massive, unprecedented, and interrelated transitions, each of which presents tremendous opportunity. So first, we're shifting from an economy that's based on fossil fuels to one that's based on clean energy. And as we've heard repeatedly today, everything depends on how quickly we can make that happen. Second, disruptive climate change is simultaneously accelerating. That trend's going to continue. So as a result, when we think about building out our new clean energy system, we have to consider that we're going to be experiencing worsening physical impacts, heat, floods, storms, and the like, as well as the impacts stemming from climate change transition risk that will affect the insurance industry, financial and real estate markets. So that really means that we have to give a lot of thought to how we're designing and engineering the clean energy systems to withstand those physical impacts. And we've got to work very hard to de-risk clean energy investments and better manage climate risk across the economy. So that's something that we're very focused on. Third, as people adapt to climate change, our societies are going to continue to experience adversity and also just rapid change. In my mind, I sometimes think of this as comparable to punctuated equilibrium. There's going to be abrupt change. Some of it might be very difficult. Some of it might be very positive. There could be technological changes that occur that we don't anticipate. So our job as leaders is to lay the groundwork for long-term, positive, transformative change that yields a lasting and fundamental recalibration of our human relationship to the natural world. You know, at the end of the day, if I were to sort of tie up all of the remarks that we've heard here today, that's really what we're talking about at bottom. So when we speak about the clean energy transition, we've got to think about that transition in context of these related dynamics. So in our role as state government, as a convener, we're working very hard to engage people in a way that both reckons truthfully with the current reality, while also, to Wade's point, building courage and hope that we can achieve a shared vision for a healthier and more equitable and a safer future if we all work hard to change course now. We really have to help people understand through our communications, through innovation, to Dan's point, and communication, how we talk to people about this so we get everybody on board with it in a way that doesn't paralyze with fear. So I want to share a few specific points about our clean energy transition. In our whole of government approach, our clean energy strategy and policy informs, and it's woven into all of our other key policy goals. So just a few examples. We're in the process, we have a very old, the oldest in the country, public transportation system. Many of you probably, if you've come to Boston, you've ridden the T. So one of the things we're doing there is modernizing that system anyway. So we are weaving into that all of our climate goals. We have a dire need for housing production in the Commonwealth, and especially workforce housing, which of course we need for clean energy workers. So we are weaving our climate goals into that, and same with stimulating economic development. So for example, our recently established long-term transportation funding task force includes planning for how to fund bus and commuter rail electrification and making that system overall more resilient to the physical impacts of climate change. Governor Healy proposed an historic housing bond bill earlier this year that includes substantial funds to decarbonize our state-owned public housing, but it also puts incentives in place for developers. So those developers that are going to come to the table willing to build new housing that is decarbonized and willing to retrofit existing housing, this is largely affordable housing, that is decarbonized, are going to come to the front of the line for low-income housing tax credits. So those are the ways that state can kind of set the appropriate incentives. As you heard also this morning, we have an economic development bond bill, Mass leads, an historic $1.3 billion investment for climate tech. And these are technologies that are already blooming in Massachusetts. And so we have a terrific ecosystem there that includes, all of the early stage financing that we've used for life sciences, the academic institutions that we have, the culture of innovation that characterizes our state. And these technologies already include folks who are working on making manufacturing processes more energy efficient, producing lower embodied carbon building materials, recycling technology for electric vehicle batteries. So this stuff is on the ground, and we just want to continue to grow that. Massachusetts state law requires us to prepare a clean energy and climate plan. It's done so since 2008. And there was intervening legislation that requires us, we have a legislative mandate to get to net zero by 2050. By shifting away from fossil fuels, which are of course price volatile, to in our power sector, our building sector, and our transportation sectors. And also by conserving our forest, wetlands, and agricultural lands that will offset any remaining greenhouse gas emissions in 2050. I was explaining to Kanjian at the lunch break, if you were to look at the graph of our emissions reductions, we have roughly 7.5 million metric tons of carbon dioxide equivalents that we never achieve by 2050 without natural and working lands. So it's critical for us to ensure that we have that carbon sequestration capacity. Roughly half of our electric load today is met with clean generation. So that is really a success story. And that reflects our significant progress to date in building renewable energy within Massachusetts, but also working with our regional partners to source clean energy. We do, however, face significant challenges in deploying clean energy at scale, as others have referenced, and at the pace that's necessary to meet our power sector interim targets, particularly for 2030 and by implication, our net zero by 2050. So for 2030, our goal is to reduce electric power sector emissions 70% from our 1990 levels to 8.4 million metric tons carbon dioxide equivalent. Without substantial additions of clean energy, and of course, we bear in mind and prioritize a need for enhanced demand-side management, that is increasing energy efficiency, we won't get there on our vehicle and building electrification targets because, of course, they rely on having an increasingly clean electric power sector to provide that energy. So, for example, from 2030 onward, we need about 1 gigawatt of both solar and wind annually in order to keep pace with electrification and reach net zero. So by comparison, the most that we've installed just for solar in a single year is about 600 megawatts. So just this year, we have our first offshore wind project, and it's only the second commercial offshore wind project in the United States. It's Vineyard Wind. Began generating clean energy. It's expected to be fully complete later this year. And at that point, we're going to be getting about 800 megawatts of clean energy generated from that project. That's enough to power about 400,000 homes, but of course, we need much more than that. So increasing cost of offshore wind due to inflation, supply chain constraints that became quite pronounced after the COVID pandemic and after the war in Ukraine have created challenges. But our response to that was to issue a new 5,600 megawatt RFP, and we're in the process of reviewing those bids right now. Siting renewable energy, as in many places, and storage can be very difficult. It can take a long time in our region, both because of delays in connecting to the grid and due to land use conflicts. So delays of up 8 years for interconnection can make projects uneconomic, particularly for solar and project developers. These delays equate to lost jobs and lost municipal revenue. They can be caused by lack of hosting capacity on the distribution system, less necessary equipment like transformers, cost allocation methodologies that don't recognize all beneficiaries of grid upgrades, historic underinvestment in distribution system infrastructure in certain locations. So we have seen some positive movement. Utilities currently deploying around $1.7 billion in grid modernization investments. That will be things like advancing two-way metering. They will help facilitate interconnection, optimization of renewables and storage. Will also pave the way for virtual power plants, very, very exciting technology, but we need them to do more. Conflicts in land use can also result in delay, so I'm going to skip ahead here because although I practiced this and it came in at 10 minutes, I'm now a little bit behind here. So I do want to tell you that in the past, we've had a lot of trouble siting solar. Long story short, the incentives really incentivize people to put solar into previously forested land. So we now know that mature forests are really doing the heavy lifting in terms of carbon sequestration. You've probably seen the study that came out recently that showed that the Northeast is, because it's reforested now after colonial deforestation, it's achieving about 1 to 2 degrees Celsius emissions reduction annually. So what we're doing now, and we've worked with a number of experts in this area, is to, and I will wrap up momentarily, is to ensure that our solar policy allows us to preserve mature forests while also building out the solar that we need. So it's another way that we've recently been able to partner with experts. So I'm going to stop there. If you'd like to learn more about other things that we're doing, I'm happy to talk to you about it. I will say 2 quick points to wrap up. The governor earlier this year issued an executive order that established a siting commission to help us solve some of these problems. It will help to expedite permitting and make it a lot easier to site these projects. And secondly, we are undertaking and exploring an effort now for a comprehensive state land use vision that will help us deconflict early on what we want to do in terms of transportation expansion, siting renewable energies, housing production, and preservation of our natural and working lands. So thanks again. We are very excited to be here. And I will just close with my thought about what guides my thinking every day. And I hear a little bit of this in what people presented, which is I ask myself the question, what would it look like if our actions in the world reflected our understanding that our own human health and thriving is dependent on the health and integrity of the natural world? Thank you.
Thank you, Melissa.
The rubber really the rubber really meets the road in those settings. So thank you, Melissa. Thank you also for being a disruptor, because it's in government. You need somebody who's going to be a disruptor, and I, as governor, need to have her back, which I do, but these are the challenges of our time. To bring us home, we have our wonderful governor from Kenya. Thank you so much for speaking and closing us out today. We had an earlier conversation about a relationship that he and I can develop, subnationals or nationals working together on some of these initiatives as we move forward. So thank you very much, Governor.
Very brief. It has been a wonderful day, and we have learned a lot. And when you see politicians sit the whole day, it means there's something serious. There's something serious. So I want to assure you that from the subnational government, we are committed. And some of us who are here, we are committed, and as we live going back, we shall spread the gospel so that people can know that climate change issues are real pertinent, and they are issues that we must all come together and move forward. We no longer, from here, I expect there shouldn't be just continued talking. The way we have been talking in the COP, I've attended so many COPs, even to COP 25, 26, 27, 28, but there is just a lot of talking. This summit must be different. It must be different. And it must be different because we politicians, very serious politicians, we are here showing our commitment that we are ready to work. So let's, as we wind up, when we finish this summit, let's come out with a communication, a communique that will send a strong message to the leadership of the rest of the world that we are serious. Climate change is a big challenge. Climate change is threatening our own survival on this planet. And if we don't take any action, we shall all perish. Whether we are from rich nations or from poor nations. We in the poor nations, we have said we will work together. We will work together because the challenge doesn't matter. I was very happy when I saw the issue of Titanic, because there were rich guys in that Titanic, but they all perished. And even the poor guys who are also doing the manual work also perished. So all of us are going to perish. So we have a responsibility to move forward. The countries that have been responsible to a large extent to climate change, they need to take responsibility. They need to take responsibility and honor their commitment. We were in Glasgow. They said that they would provide, no, it was Copenhagen, where they said they would provide $100 billion every year to ensure that the countries that suffer most, which are developing countries and countries in Africa, should be compensated to be able to come up. Nothing has happened. We were in Egypt. It was agreed that we would have loss and damage fund. To date, nothing has happened. So we need to be serious. And what is coming out clear for us who come from the South is that some of the developed countries are using climate change as a business. Medication is being given priority because it has a business component, whereby we are now being given loans to have some of the technologies, like the solar technologies. We have programs that are coming up in developed countries, but we have to pay. So this narrative must change. On renewable energy, Africa has the best opportunity in development of renewable energy. And it could be the biggest producer of renewable energy in the whole of the world. So we need serious support to be able to develop this opportunity in renewable energy. So that's an area that is of interest. Also, in terms of nature-based solutions, I think I've liked what the China representative has talked about. It's very important that we move and focus on nature-based solutions to deal with the climate change. So without having to go into details, I want to assure this audience that we in the South we have said we want to work together as partners. We have said we shall not continue now lamenting. We have lamented enough. Now let us work as partners, but let's have goodwill from the developed North, and we shall all work together. The technology is there, everything's there. And lastly, the carbon markets have come, and they are coming to Africa as a huge business. And because most countries in Africa don't understand the carbon market, they are all being taken for granted. They are signing agreements, which they even don't know what agreements they are signing. And in the process, they are going to have most of their tracts of land taken over. So we see a trend which is worrying. And therefore, we need the natural assets in Africa to be quantified and measured, particularly the forests, the savannas, the peatlands, the mangroves, so that we can be compensated, because they are big carbon sinks, which are absorbing all this carbon dioxide, but in return, we are getting nothing. So I want to stop there and look forward that when we finish this summit, I want to see communication that is going to be different and commitment that's going to be different from what we have had in COP conferences. Thank you, and God bless.
On behalf of Dr. Che Gambao and myself, we thank all of today's panelists. Thank you so much, Governor. From this Governor, this devil of the North, I guess I'll say this: the devil is in the details, and I think it's very productive to have had this conversation today and to think about the ways that we can work together going forward. Eminences, excellencies, mayors, governors, chiefs, chairs, professors, academicians, members of the Diplomatic Corps, ladies and gentlemen, that concludes our session. I turn it over to our fearless leaders if there are any further announcements.
Well, a vote of thanks, especially to the able chairpersonship of this session in the evening. Concluding remarks from the North, West, and South, and East. We have dinner together. I want to, before you go there, Sister Helen, President Helen, wants me to point out when you are to be ready tomorrow morning for the audience. Read it in the program and be on time. And enjoy the audience with Pope Francis, and then we continue at a different location. It will be a day full of additional information, commitments, serious commitments, and preparation of the communication, which we just heard as a request from the concluding statement from Mr. Otichalo. Thank you very much, and have a pleasant evening. Dinner is now at the same location.